Hello everyone, hope you guys are doing well. So here is another exam paper. So this is going to be a June grade 12. And this is a paper 2 exam that was written in 2022, 150 marks, 3 hours long. Download the paper by looking in the description below this video. Then you can at least see all the questions that are going to be coming up, and then you can fast forward to the specific part in the video that you would like to watch. Wishing you guys all the best with this exam paper, and I'll see you inside. The table below shows the mass in kilogram of the school bags of 80 learners. Okay, so we have a school where there are 80 learners, and these are the different kilograms, the different masses of the school bags. So funny story, when I was in grade 8, I'm generally, I'm shorter than, I was always shorter than most people. Or I was usually like at least the shortest or the second or third shortest in my class throughout my school career, okay? And that was usually when there were like 35 kids in my class. So I'm fairly short, okay? So like Kevin Hart type vibes. So shout out to you, Kevin. Me and Kevin are actually friends. I played golf with him the other day. Okay, that was a joke, but that would be pretty cool. So listen, I had this funny story where I got to this new school in grade 8, and I don't know what my parents were thinking, and I don't know what I was thinking, but my school bag was absolutely enormous. Like, it was huge. I think someone gave it to my parents, and I don't know why we decided that this would be a good idea to take it. But if you had to see that bag on me, I was this little grade 8, and it actually gave me a bit of social anxiety, or not. I wouldn't call it social anxiety, but I was anxious to. Whenever we had school, you know, when the bell rings, you have to walk from one classroom to another. That part gave me anxiety because I would have like these, I was grade 8, right? And I was tiny, and there would be like these grade 12s behind me, and they'd be like, bro, look at this guy's bag. It's so funny. And then they would like push on my bag and stuff. And I don't know why I just didn't have this thought of, dude, just tell your parents to get you a new bag. But I would rather like, I don't know what I was thinking, but like every day I'd get to school and I'd be like, oh, I got to change classes again. And it was so embarrassing for me. Like, this bag was really, really big. And it would like hang like below my like bum area. The bum's a funny word, or backside if you want to call it that. But it would like hang like below that. And yeah, I remember it was super traumatic. But I don't know why, thinking back now, I don't know why I just asked to get a new bag. But anyways, so here we have, okay, so we've got all these children who have these school bags, okay? So for example, there are like 19 learners, for example, whose bag is anywhere between 11 and 13 kilograms. Now, that's a heavy bag. Maybe that's what I was doing. I don't know. But like 19 kilograms, like, dude, that's the size of bag that you would take to the airport. Like, this person, maybe that was me. Maybe that was Kevin over there. Little Kevin in grade 8. Probably like, I don't know how tall I was, but I think I weighed like, geez, I don't know. In grade 8, I probably weighed like 40. I don't know, I can't remember. I know in grade 7 I weighed 35, if that gives you any perspective. In grade 7, I remember they weighed us once and I was 35. So I don't know what I was in grade 8, but probably like 40. I'm not sure. But I was small. I was one of the shortest in my grade. But this question here says, write down the modal class. So the modal class is the class that has the most people. So if you look at the 9 to 11 kilogram bags, there are 21 learners. So that is the modal class. So we'll say it's the 9 to 11 category. So you just write it exactly. Oh, and I see they've got that over there. So as they have it there. This question says, complete the cumulative frequency in the answer book. Okay, so I went to the answer book and I just got the cumulative frequency table over here. So cumulative frequency is easy. So you start with the first one, so that's 6. Then what you do is you think about, okay, if there's 6 people here and 18 people over here, then how many people would you count all together up to this point? Well, that would be 24. Right? Because I said 6 plus 18, and now we're going to say, okay, 24, and then there's another 21 people, so that's going to be 45, And then there's another 19 people over here, so that's going to be 64. Then there's 11 people, so that's 75. Then there's another 4 people, that's 79. And then there's another 1 person, and so that's 80. And that makes sense because in the beginning, in the first question, they did tell us there are 80 learners. Okay? This question says, draw a cumulative frequency or an ogive for the given data on the grid provided in the answer book. Okay, so we already had these values. Let's just go fill them in again. 624, 45, 64, 75, 79, and 80. So remember, when you do an ogive, listen carefully, guys. It starts at this number. Okay, so it starts at that number. And then you use these numbers for the rest. And then you use the cumulative frequencies over here. Because you see it says here cumulative frequency. And you see over here it says mass. But just remember to use this mass. But you start it at the 5. So you're not going to start it at the 0. You start it at whatever that number is. Okay, so we put a little dot there. Now we go to 7. Okay, so 7 goes with 6. So 7 on the x-axis. And then 6 on the y-axis. So that's going to be there. Okay, then we're going to do 9 and 24. So 9 on the x-axis and then 24 on the y-axis. That'll be there. And then 11 and 45. So that'll be like that. And then 13 and 64. Okay, so let's quickly take that away now. 13 and 64. So 13 on the x-axis. And then 64 on the y. 15 and then 75. And then 17 and 79. And then 19 and 80. Okay, so 19 and 80 over there. Okay, then we're going to try to draw a line through a nice curve through all of that. And there we have it. Okay, now we have another question down here at the bottom. It says, use the graph to determine the median mass for the starters. You're not going to use this. You're going to use the graph to determine the median. Now, how does median normally work? Well, if I gave you like a whole bunch of values like this, then the median is the number that is in the middle. Okay? So you got to think about this really carefully. How would you find the median though? Like let's say there were a lot of, okay, well obviously you could see that the median is 11, right? But that's just because we have a little bit of numbers to choose from. But what's important is that there's this formula that you can use to find the median, which is n plus 1 divided by 2, right? So you got to think about this carefully. Where does this n come from? What would I have used as that n value? Well, you would have used 1, 2, 3, 4, 5, 6, 7. So you would have said 7 plus 1 over 2. Okay? So where did that 7 come from? Well, 7 is the number of items that we have. So you got to think about how many items do we have? Are we going to say 7 or 13? No, these are the masses of the bags. We have 80 items or 80 learners, so there are 80 school bags. So that is where you're going to do this. So you're going to say 80 plus 1 over 2, and that's going to give you 81 over 2, and that's going to give you 40,5. So you're going to go to a cumulative frequency value of 40,5. So you're not going to go on this axis, you're going to go on this axis. It's really important that you think about that. So you're going to go at about 40, okay, or just above 40, and you're going to read it off there, and then you're going to go down. So you're going to go down, 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 down. And so that's between 10 and it's between 11. So that's going to be 10,5 kilograms. 10,5 kilograms. Now, of course, in the test, you might get that a little bit off. So on the memo, they will allow you to get the following answers. All right, soldiers, so I went to the battlefield to go see what I could find for you, but to be honest, the only answer they actually wanted was 10,5. So, yeah, normally they give you a range of answers that you're allowed, but this one was just 10,5. And make sure you understand what I said over here about knowing what is your value of n, okay? N is the number of items. It's not these numbers here. It's the number of items. So you count 1, 2, 3, 4, 5, 6, 7. That's how you calculate n, okay? It's got nothing to do with what these numbers actually are. So like you don't say, oh, 8 or anything like that. Okay, let's move on. So this question says that the international guideline for now this is something my parents should have read when I was in grade 8. The international guideline for the mass of a school bag is that it should not exceed 10% of a learner's body mass. First question says calculate the mean of the school bags. Now, how do you calculate the mean from a table? Well, remember, from like we probably started learning this in grade 10, is to calculate the average, you've got to think about it like this. There are 6 learners over there, and some of them, they have a mass anywhere between 5 and 7. So what you do is you take the middle number, okay? So 6 kilograms, that's how heavy the bag is. But how many learners are there with a 6 kilogram bag? There are 6 of them. So you could imagine that we would have said 6, 6, 6, 6, 6, 6. Then there would be 18 learners who have an 8 kilogram bag. Now, obviously, I'm not going to go write that out 18 times. But if you had to then go calculate the average or the mean, you would have added all of these numbers together. So what is a fast way to do that? Well, you can say that there are 6 learners with a 6 kilogram bag. So you can just say 6 times 6 plus. Then there are 18 learners with an 8 kilogram bag. And then there are 21 learners with a 10 kilogram bag, and so on and so forth. You understand, right? So 11 times 14 plus 4 bags that are 16 kilograms plus 18 bags times 1. But now, if you did have to go add all of that together, what would you have divided the answer with at the end? How does average work? Well, you would have divided by how many items there are. How many items are there again? Well, we said if you add up all of these, there are 80 learners in total, so you would divide that by 80. Okay, let's take out our calculator and let's go spend the next 25 minutes typing all of that in. Okay, that was a joke, but yeah, it's a lot of stuff to type in. Okay, so at the top, you should get 854. So if you work this out and you round to 2 decimal places, you should get 10,68. This question says that the mean mass of this learners was found to be 80 kilograms. Okay, so there's 80 learners. So don't get confused with this 80 and the 80 learners. That's just a coincidence. So the average of these kids are about 80 kilograms. So on average, are their school bags satisfying the international guideline? Well, what we need to do is work out what, out of the person's average weight, or mass, sorry, for those of you that do physics, you know mass and weight is different, right? So I just made a critical error there. Okay, but that's not important right now, Kevin. We're doing maths, bro. Okay, so most learners are 80 kilograms, but the average bag mass is 10,68. So if you had to work that out, and then to get a percentage, you obviously say times 100. So if we had to go work this out, so these learners, most of their bags are around 13.35%. So these poor learners, they're carrying around bags that are too heavy because the international guidelines says that a school bag should not be 10% or more than 10% of a learner's mass. But these bags are on average 13.35% of a learner's mass. And so on average, are the school bags satisfying? So we'll say no, the school bags are not satisfying. I'll just say the guideline. Okay, so you'd obviously show the calculation and then you would give a conclusion over there. Okay, so here we have this question. Now, just look carefully. There is the question over here at the bottom. So I just had to try fit everything onto the screen. So it says here, the table below shows the size in carats. Now remember, we're not talking about vegetables or things like that. We're talking about carats as in, carat diamond that people talk about. All the bling bling. So the table below shows the size in carats and the price in rands of 10 diamonds that were sold by a diamond trader. So here's the 10 diamonds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They've also given us a scatter plot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this data or data is just there. It's the same thing. They say here this information is also presented in the scatter plot. Okay, so it's all just the same thing. The least squares regression line for the data is drawn. Okay, so the first question says, determine the equation of this least squares regression line for the data. So remember, this is all a calculator thing, so you are going to put your calculator into stat mode. Remember, on a Casio, if you can't remember how to do that, you're going to say mode. Then you're going to push the stat button. And then because it's grade 12, not grade 11, you're going to push A plus BX. So you're looking for A plus BX. That is the regression equation. So you're going to push that option on your calculator. Then you should see that you're going to have an X column on your calculator and a Y. So they've told us that the top one is X, the bottom one is Y. So go ahead and enter all of those values. I'll see you a little bit later. Okay, so once you've entered all of those values, then you need to tell your calculator, hey calculator, I need you to give me the A value and the B value. So the way that you do that is you push the on button, okay, so it takes you away from the screen where you were busy entering all the values. And then, so I thought I'd actually just try find a calculator and then actually show you. So I've entered all the values already. Now we need to go tell the calculator, hey calculator, I need the A value and I need the B value. So now you're going to press the shift button and then the 1, and then you're going to not press number 4. That would only be if we were busy with grade 11 statistics, but rather number 5, which is regression, because we're looking for the regression line. So push number 5, and there's the important parameters that you may be asked to find. So to find A, you're going to press number 1, and then you press equals. Okay, so I'm going to quickly write that number down. And then we're going to go find the B value. So you can press shift again and then press number 1 and just go back to the same screen that we were at and then press number 2 this time, then press equals, and there's your B value. I'm just going to write that down and then I'll put it on the screen for us shortly. And so the value of A, if we round to 2 decimal places, was 634.38. And the value of B was 32189.26. So now when you write out the formula, or the least squares regression equation, it's y equals to A plus bx, okay? So that's going to be y equals to A, which is 634.38, plus B, which is 32189.26x. This question says, if the trader sold a diamond that was 0.25 carats, predict the selling price. Okay, so remember that this is the selling price, and then X, if you look at what X is the size in carats. So we can use our formula now, and that's going to give us, I mean, you could also look with the graph, I guess, at 0.25 carats. But I wouldn't do it that way. And I looked at the memo as well, and they want the specific value. So you're going to use your equation that you generated in the previous question. And so you're going to say 634.38 plus 3218. And then the X is your carats, which is the 0.25. Okay, now you can go and type that on the calculator. And that would then give you 8681.70, and that's Rand. This question says, calculate the average price increase per 0.05 carat of the diamond. So what they want to know is, as the price of the carat changes by 0.05, what happens to the average price? So what I would do is, we know from the previous question that a 0.25 carat had a price of 8681.70 Rand. Okay, so then I would just increase that by 0.05. So I would go up to 0.3 carat. Don't use the... That's not how you spell carrot. That's so embarrassing. It's carrot. I forgot that we're not dealing with the stuff, the carrot you eat, but rather these carrots. Okay, so 0.3 carat. Because why did I say 0.3? Because that's the increase of 0.05. Okay? Don't use the table. You must use your formula, which was y equals to 634.38 plus 32189.26x. So we're going to go see what happens when the carat is 0.3. And so that's 10,291.16. Okay, so look at when it was 0.25, that was the price. When it was 0.3, that was the price. So how much did it increase by? Well, if we say 10,291.16 minus 8681.70, you end up with 1,609.46. So it says here in the question, calculate the average price increase when you increase the carat by 0.05. And that's what we've just done now. We looked at the price at 0.25 and then we increased that by 0.05, which is what they said, and that became 0.3. We calculated what that would be worth, and then we just minus them to see what is the increase from, whenever you increase by 0.05. This question says that it was later found that the selling price of the 0.35 carat was recorded incorrectly. Okay, so let's go to the 0.35. Oh, and there it was recorded. Remember, there was a value of a table of values, but those values are exactly what we see here. So at 0.3, it was originally, 0.35, it was originally recorded at 10,000 Rand. But they say that the correct price is 11,500. Okay, so that's going to be, where's 11,500? So, well, there's 11,000, and then that would be 500. So it would be there instead. Okay, so that's the correct price. When this correction is made to the data, the correlation between the size and price of these diamonds gets stronger. Explain this reason by referring to the given scatter plot. Well, the way it works is that, let's say this dot over here. Okay, so remember, you've got all these dots, right? You can see all these dots over here. Now this line is trying to get as close to every single one of those dots as possible. That is what it's trying to do. And okay, so these little distances between the dots and the line, the less that, or the smaller that those values are, the more accurate this line actually is. Okay, so if you take this dot and you had to move it down here instead. Okay, so let's just erase where it was. Then what that would do is that this line over here, would try to get as close to all the dots as possible, but it's also going to try to get close to this dot. And so maybe the new line would go like that. And so this is going to make the line less accurate, because now it's not really that close to these dots, because it's also trying to get closer to this dot. But if you move this dot a little bit closer to the line, so maybe like that over there, then this whole thing becomes more accurate, because now this line over here can get even closer to all of these dots. So the reason that this makes the correlation between the size and the price get stronger is because the new price is closer to the regression line. Okay. All right, so with this question, there will be more questions on the next slide. I just didn't fit all of them onto one page. So it says here that in the diagram, we have A, B, and C. Okay, A, B, C, sorry, that was weird. A, B, C, we don't know the coordinates, and E, okay? And then D is the y-intercept of that line over there. All right, then what else they tell us? It's the vertices of a trapezium, and these lines are parallel, as they've showed us over there, And this is important. CD and DE are the same. So CD, that length, is the same as that length. Okay, keep that in mind. So the first question for 2 marks says calculate the gradient of AB. Okay, so that's a very straightforward question. But of course, when you're in an exam, make sure not to make any small mistakes, okay? So we know how to do the gradient. So I'm just going to say 3 minus a half over 5 take away 0. And so that's going to be 2.5 over 5, which is a half. Okay, so that will be a half. This next one says determine the equation of CE, okay? Now, we know that it's a straight line, so it's y equals to mx plus c. We also know that these 2 lines are parallel. That means that they have the same gradient. So we can say for CE, whoa, careful, what's going on, dude? CE, there we go. The gradient is a half, but we don't know what the C value is. However, the way to find C is that you plug in any point on this line. We do have this one over here. So the minus 4 is your y value. The 6 is your x value. And so here you'll end up with negative 4 equals to 3 plus c. Take the 3 over and you're going to end up with c equals to negative 7. And so that answer would then be y equals to a half x take away 7. This question says calculate the coordinates of C. So what we can do here is we can first go calculate the coordinates of D because that is the y-intercept of this line. Okay, so you could say y equals to a half x minus 7. Then to find the y-intercept, we just make x equal to 0. And that'll give us negative 7. So the coordinates of D will then be x is 0, y is negative 7. Now, remember that D is the midpoint of C and E because they told us that this distance is the same as this distance. So we can use the midpoint formula, which is x1 plus x2 over 2 and y1 plus y2 over 2. But we're going to use it in reverse because we don't know what the coordinates of C are. So we'll just call it x and y. So normally you would say this x plus this x, you would divide that by 2 and that would give you the x value of the midpoint. But we know that that is equal to 0. So you just do that. Then you just use mathematics to now solve. So you take that 2 and you multiply it across. So that'll be x plus 6 equals to 0. Take the 6 to the other side and you end up with negative 6. Okay, so this x value here is negative 6. Now to find the y, you do the exact same thing. So you would normally use this formula here. So you would say y plus this one's y over 2, and the answer is supposed to be whatever this y is. But we know that that y is negative 7. So now you can just solve. Remember, a plus and a minus is a minus. So you can take this 2 across now. And so you can say y minus 4 is equal to negative 14. And then you take the minus 4 over. And so y would become negative 10. And so x is negative. So the coordinates of C would be the x value is negative 6. And the y value is negative 10. The next question wants us to calculate the area of ABCD. So A to B, then to C, and then to D. Okay, so they want the area of that shape. Okay, so we can break this up into 2 triangles. So for example, let's look at this first triangle, which goes up to there, and then to there, and then to there. Now there are 2 formulas when calculating the area of a triangle. The first one is half base times height, and then the trigonometry one is half AB sin C. Now, we don't really have any angles, and so it typically is not going to be that one over there. Okay, but the problem with this one is that you need to have a base and a height which are perpendicular. Now we can see that there are no 90-degree angles. However, sometimes, or with triangles, if you have a triangle like this, then what you can do is you can still let this be the base, for example, and then the height is always it's always from the opposite corner, and it must hit the base at 90 degrees. Like that. And so that would be your height. Even though it's not part of the triangle, that is still the height of that triangle. And so that is the height that we are looking for. And so your height does not need to be part of the triangle. So what we could do is you could, for example, say that this is your base. From B to D. That can be your base. Okay? Then you take from the opposite corner, and you need to go at 90 degrees to that base. And so this can be your height. Okay? And then your base is up to there. So let's take away that line. Does that make sense? So we could then say that the area of triangle CBD is going to be half base times height. And so your base length is going to be from here to here. So it's from a half to -7. So that's going to be 7.5. So you could just say 7.5. And then your height length is literally just going to be from here to here. Now, we don't know the exact coordinates there, but what do we know? We know that this is a perfectly horizontal line. How do we know that? Well, we know that this is a perfectly vertical line. And so for those two to be 90 degrees, this line has to be perfectly horizontal. So can we all agree that this y value is going to be exactly the same as this y value over here? So that's -10. And then this is on the on the y-axis. So this has an x value of 0. So then what you can do is you can just look at this horizontal distance, and can we agree that that would be 6? Because this is -6 and this is 0, so that's going to be 6 units long. So we can say times 6. And if you had to work this out, that is going to be 22.5. And then yes, we can just say units squared. Okay, now let's say units squared instead. Okay, now we need to find the area of the other triangle, which is going to be triangle DAB. And so here we can do the same thing. You can let this be your base up to there, and then just to pretend that that was extended a little bit. Then go to the opposite corner, and then put a 90-degree line like that. And so there would be your height, and then you could use this length as your base. And so the area of triangle B or DAB would be half base times height. And so your base length is going to be from D to B once again. So that's going to be 7.5. And then for the height length, so you see that these two are the same because they're on the same horizontal level. But if you look at the x values, it goes from 0 up to 5. So that's going to be a length of 5. And so that's going to give you 18.75 units squared. Okay, now to find the total area of A, B, C, D, you're just going to add those two together. So 22.5 plus 18.75. And that'll give us 41.25 units squared. Let's write that a little bit better, 41.25. This question says that if point K is the reflection of E in the y-axis. Okay, so here's point E. Now, if you reflect that in the y-axis, it's going to go this way to somewhere over here. Okay? We can quickly go get, here they tell us to get its coordinates. Okay, that's really easy. So you're just going to reflect it. And so this distance must be the same on the other side. Okay. So you see this horizontal distance is 6. Why do I say that? Well, we know that this x value is 6. This x value here is 0. So that is a horizontal distance of 6. And so you do the same on that side. So it would end up going to negative 6 for the x, and then the y would stay negative 4 because it's on the same horizontal level. Okay, you might be saying, yeah, but how do you know it's on the same horizontal level, bro? Well, remember, we're reflecting across the y-axis, which is completely vertical, and when you reflect, you always hit something at 90 degrees, so that means this line must be perfectly horizontal. Okay? So that's that question. Then it says calculate for 4 marks, the perimeter of triangle KEC. KEC. Okay, so this is, we know that this is K. So from K to E to C. And the coordinates of C we have from earlier, negative 6, negative 10. Okay, so the distance from K to E is going to be a very easy one because we're just going to go 6 units that way, 6 units that way. So that is going to be a total length of 12. Okay, now we need to go find the distance of CE. So we can just use the distance formula. And that's the formula that goes like this. Okay, and so I'm just going to use point E first. So that'll be 6 take away negative 6 plus negative 4 take away negative 10. Then just go ahead, type that in the calculator. And I'll just leave it as in the root form. So that's 6 square root 5. And then we just need this distance over here. But that's an easy one because you see the x values are the same. So you just actually need to look at the y values, which is going from negative 4 to negative 10. So that is a length of 6. So the distance of CK is 6. So the total perimeter, then you just add these numbers together. And so let's just do that. And so that'll be 31.42 if you round to 2 decimal places, and we can just say units. This question says, calculate the size of angle KCE. So K to C to E. So they want to know, what is the size of this angle? Well, remember that this line here is perfectly horizontal, and this line is perfectly vertical. How do I know that? Well, if you look at the x values, they're staying the same. So if you have a perfectly horizontal meeting a perfectly vertical, then this angle is 90 degrees. That then means we can go all the way back to grade 10 trigonometry. We don't have to use grade 11 trigonometry. If you wanted to, you can. It just takes a little bit longer. But we can go back to the old school ways of using SOHCAHTOA. Okay, so we're trying to find this angle. And so it's pretty easy. You could use, we know all the lengths of the triangle, but I'm just going to take, so we're trying to find this angle. I'm going to use this length over here, which is the opposite. And then I'm going to use this length over here, which is the adjacent. But you could have used the other lengths as well. So we're using opposite and adjacent, so that's tan. So we can say tan of angle C, or KCE, is going to be equal to the opposite, which is the length of KE, remember this is K, over the length of the adjacent, which is KC. And so the length of KE is 12. The length of KC was 6, because it's negative 4 up to negative 10, so that's 6 units. And so if you then say shift tan, so it'll be tan, inverse tan of 12 over 6, then you would get, so you have to press shift tan of 12 over 6. You're going to get 63.43 degrees. Just remember that this question will carry on. So let's start with this first one. So it says, in the diagram, the circle centered at M, which is A and B, is drawn. Then they've given us point T, point R, and they say that those are the x-intercepts. And then they say that a tangent is drawn over there. Okay, so M is a point on the line y equals to x plus 1. So M is a point on the line y equals to x plus 1. Okay, so there is some line going through M, okay? We don't know which direction it's going. It's going to be something like this. I know that because I see the gradient is positive and I see the y-intercept is 1. Okay, but that doesn't really matter. So that's a line y equals to x plus 1. So it says write b in terms of a. So what you do is you realize that a is a x value, b is a y value, and you go plug that in over here. So b is the y value, a is the x value. Okay? And so it says write b in terms of a. Well, there we've done it. B is equal to a plus 1. This next one says calculate the coordinates of m, and that's for 5 marks. So I think what we can do is, because it's a circle, we know that this distance, from m to k, must be the same as the distance from m to r. Where am I going? There. Those distances must be the same because this is the center and those are on the outside of the circle. So I think that's the approach that'll work quite nicely. So we could say that mr, the distance of mr, is the same as the distance of mk. Now we can go set up our distance formulas for both of those. So mr, okay, so we're going to use, so remember the distance formula. Let's first go write out our distance formula. So that's x2 take away x1 plus y2 take away y1. Okay, so now we can do that for, let's go do it like this. I'll separate it. So we'll do it for mr, and then we'll do it for mk, and then we'll make them equal. So for mr, I'm going to use, okay, so we can say a take away 6 plus b take away 0. Okay, now I'm going to do it for mk. So we can do a take away 5 plus b take away 7. We're then going to make those two expressions equal to each other. We just mustn't confuse that this is a 6 and this is a b. They look exactly the same. Okay, so let's, this is a 6. And then b, I'm going to use a capital B. Okay, just in case. And then here I'm going to use a capital B as well. Okay, so then that's a minus 6, and then b take away 0, and that's going to be equal to mk, which is a take away 5 plus b take away 7 squared. Okay, now in mathematics, when you have a square root on both sides, you can imagine that we just square both sides, right? And what that does is it just gets rid of the square roots. So if we then put that over, if we then write that over there, that would give us a take away 6 plus b take away 0 is just b, right? So I'm just going to do that. Whoops, equals a take away 5 plus b take away 7 squared. Okay, so now we're just going to go simplify a little, or you see, the problem is not the problem, but we have two unknowns. We don't know what a is, and we don't know what b is. So we need another equation, but that is the equation that we learnt about earlier in this first part. So we can just replace all of the b's with a plus 1. Okay, so all of the b's are going to be replaced with a plus 1. So here we go, a plus 1. And then here's another b, so we can replace it with a plus 1. Okay, now we're just going to go, I'm going to quickly simplify this if you don't mind. So positive 1 take away 7 is negative 6. Okay, now, oh, that's nice. You see how this is the same on both sides? So we can cancel that out, because if you take the 1 to the other side, it would become a negative. And so that would all cancel out. And so we're actually just going to be left with this. Okay, now some learners might say, oh, we can just take the square root on both sides here. That is fine, but remember to put a plus minus in front of one of those square roots. I'm rather going to multiply this out. So remember, there's two brackets over here actually. So a plus 1 and another a plus 1. And then here we have a take away 5 and a take away 5. And so that's going to become a squared plus 2a, because it's a squared and then a plus another a is 2a. Plus 1, and then on this side you have a squared take away 10a, because it'll be minus 5a minus another 5a, which is minus 10a, and then plus 25. Okay, now these two a squares are going to cancel as soon as you take one of them to the one side. So I'm just going to ignore them. I'm just going to scratch those out. I'm then going to take everything, well, I'm going to take all the a's to the left. So this 10a would become a positive 10a. And then I'm going to take this 1 to the right, so that'll become 25 minus 1. So then we end up with 12a equals to 24. Divide both sides by 12, and a would be 2. I'm then going to plug that answer into here. So we know that b is equal to a plus 1. So then b would be equal to 2 plus 1, which is 3. And so a is 2, b is 3. So a is 2, b is 3. So that would be the coordinates of M. Okay, this question would like us to calculate the radius of the circle. Well, that's just finding the distance. So I know we did write it earlier, but I'm just going to go write out the distance of MK. And so that would be 2 take away 5 plus 3 take away 7. And if you had to go fill that all in, you're going to get 5. And so we can just say that the radius is then 5. This next question says calculate the length of TR, so from there to there. So we need this coordinate, T's coordinate. Now remember that T is not part of the diameter. If you look carefully, going there and then going there, you see it's not necessarily part of the diameter. And they would have told us. But we do know that it's the x-intercept. So what I think we should do, because we know the radius of the circle, and we know the center, then we can use the circle equation. So we know a circle's equation goes like this. Okay, but we know everything. So we know that, and we know that the radius is 5. So if you say 5 squared, that's 25. Now we know that t is an x-intercept of the circle. How do you find x-intercepts for anything? Well, you make y0. So we're going to make y0. Okay, and so that gives us x take away 2 squared plus, this will become 9. We then take the 9 to the other side, where we end up with 25 minus 9, which is 16, right? I'm then going to take the square root on both sides. Remember, when you take a square root, just put a plus and minus, and then you square root there. Now that square root, you didn't have to do it like that, by the way. You could have, let me just rewind there. You could have also multiplied this out if you wanted to. Okay, some learners prefer that way. So I'm just going to use this technique where we have a plus and a minus there. And so this 2 is cancelled out by the square root. And so we end up with x take away 2 equals to plus or minus the square root of 16, which is 4. And so if you had to solve for x, you're going to end up with 2 on the right, and then plus or minus 4. So your first answer would be 2 plus 4, which is 6. And your second answer would be 2 minus 4, which is negative 2. So this is the 6, which we already know, which they told us is the x-intercept. And then the other x-intercept would be t, which is at negative 2. So that is negative 2 and 0. By the way, I don't know how they did this for only 2 marks. It's a bit crazy. But now we can work out this horizontal length, because you see that the y values stay the same. It's 0 and 0. So here you're going from negative 2 up to 6. And so that is a horizontal distance of 8. So the length of TR is 8. This question says, determine the equation of the tangent to the circle at K. Okay, so it's this tangent over here. Write your answer in the form. Okay, so tangents are really easy to circles. We've looked at this before. So remember, we know that a tangent is perpendicular to the radius. So if we know the grade, so remember that these two make 90 degrees. So if we know the gradient of MK, let's go work out the gradient of MK. And that use the formula y2 take away y1 over x2 take away x1, which is then going to be, for example, 7 minus 3 over 5 minus 2. And that's going to give us 4 over 3. So that means that we can then say that the gradient of MK multiplied by the gradient of the tangent is always going to be -1. We've learnt about that since since earlier grades, right? Like grade 9, grade 10, where two lines are perpendicular. And we can say here that tangent perpendicular to radius. That's the reason, okay? So we can then say that the gradient of mk, which is 4/3, multiplied by the gradient of the tangent, which we don't know. Then if you had to go work out the gradient of the tangent, it would be -1 divided by 4/3, and that's going to end up giving you -3/4. So now we have the gradient of this line. Don't know why this is 5 marks. I mean, I guess you could get marks for all of this. So you could say y equals to -3/4x plus c. Now remember, to work out the value of c, you need a point on this line. Can you see one? Can you see one? Ah, look at that. There it is. So 7 is the y. 5 is the x. And so now we can end up with 7 equals to, now if you just type this on the calculator, it's going to be -15/4 plus c. You then take this over to the left, and so c would be 43/4, or 10.75. I actually like that, 10.75. Okay, so then the final answer for that one would be y equals to -3/4x plus 10.75. This question says that a horizontal line is drawn as a tangent to the circle M at the point N, okay, where we don't know where that is, where D is a negative number. Okay, so they're saying that it's a tangent, okay, and it's horizontal. So that could only be there or there. Now, I know that it's this one. Why? Am I a magician or something? Nope, because they told us that D is smaller than 0 and D is the y value. So here the y value would be positive, right? Because, for example, if there's where the tangent is, this y value is positive. So it's not this one. So it must be this line over here, where D is, the y value here would be negative. And they said that the y value is negative. Okay, so it says write down the coordinates of N. Well, I know that this line is completely vertical like that, and this line is completely horizontal, because they have to make 90 degrees, because this is a radius and this is a tangent. So now it's pretty easy to look at the coordinates. If you go vertically straight down, then the x value stays the same. The x value would have to be 2. Then to work out this part, to work out this y value, you just look at the radius of the circle, which we said earlier is 5. And so you just go 5 units down from 3. And so this should end up being -2. And so the coordinates would be 2 and -2. This question says, determine the equation of the circle, which is centered at point N, which is this one over here, and it passes through T. So it's a circle that goes where this is the center, okay? Let me just get rid of that. So that's the center, and it passes through T. So it'll be something that looks like that. Okay, now it's only for 3 marks. So we know that a circle's equation goes like this, where these numbers are the centers, okay? This is the x value of the center, this is the y value. So we can say x take away 2 plus y take away -2. You see what I did? I just filled in those values into the center. Into the circle equation, okay? In the next line, I'm just going to change this negative to a positive. Okay, now we have one more unknown, but remember we have a point that the circle goes through. So we can just substitute that point. So this is a x value, this is a y value. So we could say -2 take away 2, and then the y value is 0. You see what I did? I just went and substituted this point into there and there. And so now you end up with -4 squared plus 2 squared equals to r squared. If you just go type this in on your calculator, you would end up with r squared is equal to 20. Now, I'm not going to get r by itself because they didn't ask me for, well, they didn't ask us for the radius. They just want the r squared. They just want the circle equation. So we can then just say x minus 2 plus y plus 2, which is what we had over here. And then r squared is 20. And there we go. In the diagram below, P is a point on the Cartesian plane, R is a point on the positive x-axis, such that obtuse angle POR, okay, there we can see it, is theta. Okay, calculate without using a calculator the length of OP. Okay, so with any of these types of questions, all you're going to do is just make a little triangle, and that triangle must always go vertically down. So for example, you're always going to have a triangle that goes vertically down, or vertically up, or vertically down, or vertically up. You're never ever going to go horizontally. So you're never going to go like that. Okay, you don't want to be doing horizontal. You just want to be doing vertical, 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 and vertical. Remember, vertical means up and down. Okay, so we made a little vertical triangle. There we go. Now, you got to look at this and see that this is an x value. So if you start over here, how do you get to that point? Well, you would go 7 units this way, and then you would go 4 units this way. Okay, 7 units that way and 4 units that way. So this length is 7, but you can just put a little -7 here, and then this length is 4. So if they want you to find the length of OP, you can just use Pythagoras. So we can just say 4 squared plus and then -7 squared, and if you work that out, that'll be 65, and then just take the square root of 65, because remember with Pythagoras you need to take the square root, and that'll just stay square root 65. But if you want to write that to 2, or let's leave it as square root 65. Okay, so that would be the answer of OP. The next question for 1 mark says, what is the value of tan theta? Okay, so remember when theta's over here, you can actually just pretend that we are using this angle in the corner. And so they just want to know tan. So you can just think of the grade 10 formulas that we learned, SOHCAHTOA. So they want to know what is tan theta. So tan is this one. So you could say tan theta is equal to the opposite over the adjacent, which is -7, and then stop. Because many learners, they want to then go further and start working out the angle. But they're not asking you for the angle. They're literally asking you for tan theta. And look, we found tan theta. If you had to go to the next step and start using shift and all of that, then you are finding theta. But that's not what they asked for. They specifically asked us for tan theta. Alright, so this next one's very interesting. So it's not difficult, but a lot of learners make a certain mistake, and I'm going to show you what that mistake is. So we know that on our cast diagram, we've got some basic things, and that is 180 minus theta, 180 plus theta, and 360 minus theta. Now, if you've watched any of my lessons before, you would know that what I've said is that if this thing in the bracket does not look exactly like one of those, then you need to change it by either adding 360 or minusing 360. I don't want to see, or what a lot of learners do is they think, oh, I'll just take out a common factor. And I've said this before, guys, you are not allowed to take out a common factor when you are busy with trigonometry. It doesn't work. I'm not saying you can't take out a common factor when you have something like cos theta plus cos squared theta sin theta. Here you could take out a cos theta as a common factor. What I'm saying is you can't take out a common factor from a bracket like that, from the angle, okay? So please don't make this a negative and then change this to 180 minus theta. Yes, it sometimes gives you the correct answer, but it's a complete coincidence. And when your teacher's marking, they're literally just going to mark it wrong. Okay, it's a coincidence. So what you need to do is you need to modify it like this. Okay, so please remember that, guys. A lot of you forget this. So what you're going to do is you are going to add 360. So you could say theta minus 180 add 360. Why are we allowed to add 360 or minus 360? It's because of the following. If you are over here, let's say you are someplace over here, if you add 360, you're going to be at exactly the same place. And if you minus 360, well, you're still going to be at the same place. So mathematically, it's all the same. And so it's a little trick that we do. So now if you had to go add all this together, you're going to end up with theta plus 180. Now, I know that this doesn't look exactly like that, but in mathematics, when you add, order doesn't matter. For example, 3 plus 5, that's 8. What's 5 plus 3? That's also 8. But when you minus, the order makes a difference. So 5 minus 3 is 2, but what's 3 minus 5? Negative 2. You see there's a difference when you subtract, and that's why we cannot just switch these around. Okay, now that you have them like this, you are allowed to switch it around, because when you add, order doesn't matter. There we go. Now all of a sudden we have something that's on our diagram, and that's what we want. So we know that because it's on our diagram, we can just say that cos 180 plus theta, you can just change that to cos theta. But we know that this is the sin quadrant, this is the tan quadrant, and this is the cos. So cos is negative in this quadrant, so we're going to put a little negative in the front. Now, I know some of you might get that answer by taking a negative out and doing all of that stuff, but it's completely wrong. It's just a coincidence that it's working out, okay? And your teacher will mark it completely wrong. Okay, so please remember that, guys. There's your answer, and remember to show your steps like that. And so now that we have negative cos theta, we can go answer their question. So we know that this changed to negative cos theta. And so that would then be negative. Now cos is adjacent over hypotenuse. So if you look at this angle here, adjacent is negative 7. And then hypotenuse is the value that we calculated earlier. And that's always a positive. So that would be square root 65. And so that's going to give you a positive 7 over square root 65. Now, if you type this on your calculator, calculators don't like to have square roots in the denominator, and so they will change it. But that is how your teacher would realize that you used a calculator. So rather leave it like that, because as soon as you type it on the calculator, it's going to try to change that. Determine the general solution of the following, and it's for 7 marks. Okay, so when I look at this, it's quite interesting to try to think about what we need to do. But just, I was looking at it and I'm thinking, what could work? But then I realized, I'm just quickly writing down the question. Then I realized, let's try this. Okay, I'm not saying it's going to work, but it might work. So if we take out a common factor on this side, that would be sin. That would be your common factor. What would you be left with? Cos x plus 1. Then on this side, you can take out a common factor of 3 cos x. What would you be left with? Cos x plus 1. Now, listen carefully, please. A lot of learners, what you guys do is you would try to cancel these two because you would see that they're the same. That is not allowed, okay? It's like maybe you've watched some of our videos where I've said that a lot of learners, when they get a question like this, they just want to cancel these x's. But if you know the right way to do, what is the right way to do it? The right way is to take everything to the one side and then factorize, okay? So you're going to do the same approach here. We're going to take everything to the one side, and then we are going to factorize. So the reason we can factorize is that we've got this term and this term, which is common. And so we're going to take out a cos x plus 1, and then we'd be left with sin x, take away 3 cos x. Okay, now just in normal mathematics where you have like a bracket of x minus 1, x plus 3 equals to 0, what would you do at this time? No, you wouldn't multiply the brackets out. You would rather say that x minus 1 is 0 or x plus 3 is 0. And we're going to do the exact same over here. And so I'm going to say cos x plus 1 equals 0. And then I'm going to say sin x minus 3 cos x equals 0. So for this one, you're just going to go take the -1 to the other side. There we go. And then for this one, you see we have a sin and a cos, and the angles are the same. That's going to be a tan. So the way you get a tan is you take this 3 cos x over to the other side. Okay, now, if you've watched any of my videos on solving general solutions, you would have come across some types of lessons where I tell you what I suggest you do whenever you end up with a 1, a 0, or a -1. Can you remember? Well done if you can remember that. I don't suggest you do the normal reference angle quadrant method. You can if you want to, but there's a better way, a faster way, and that is to just quickly draw a sketch graph. So this is a cos graph, which always starts up here at 1, and then it does this. So where is a cos graph equal to -1? Well, that would be over here. Now, if you know your cos graph, you would know that this is 90 degrees, and this is 180, okay? And then this is 270, and that's 360. So this would be 180. Now, where would that repeat? Well, the graph would continue to go like this. So this would be 360. I'm just going to put it over there instead. That's 360. Another 90 would be 450. So that would be 450. And then another 90 would be 540. So what is the horizontal distance between that? Well, if you go from 180 to 540, how much is that? Well, that's 360. And then if the graph had to continue, it would keep repeating every 360 degrees. So what we can say is that cos is equal to -1. So you say whenever the angle is 180 degrees or any multiple of 360. So any multiple of 360 degrees, and then you can just say k is an element of z. So that means that the first answer is 180. And then if you want more of answers, you can just plug in different numbers for k, like 1, -1. If you say -1, it would go that way. If you say -2, it would go that way as well. If you say +1, it would go to there. If you say +2, it would go to there. If you say +3, it would go to there. So that is literally the answer for this one. You don't need to do any quadrants. You don't need to do any reference angles. The graph takes care of that for us. And I recommend you use the graph method whenever you have a 1, -1, or a 0 over here. Okay, so with this one, we said that we're going to get tan. So to get tan, you divide both sides by cos. And so this would be, if you divide by cos, and you divide by cos, then you end up with tan over here. It's only a tan because these two angles are the same. If those angles are different, then you cannot use the tan method. Then here your coses will cancel out, and so you end up with a 3. Now you have to go to your reference angle. So this is where you'll say shift on a Casio calculator, tan of 3, and if you enter that, you're going to get 71.57 degrees. 71.57 degrees. So that's your reference angle. Now remember, tan is positive in the first quadrant and in the third quadrant. But remember that with tan, it is nice because you only have to use one of those quadrants. If you forget about that and you use both quadrants, they will never ever penalize you because it's not wrong. It just takes a bit of extra time. Okay, that's all. So I'm going to quickly carry on over here. So I'm going to choose quadrant 1. Why? Quadrant 1 is just so nice to work with. So in quadrant 1, you don't say 180 minus, 180 plus, 360 minus. You literally just go straight to the reference angle, which is 71.57 plus. Now remember, with tan, we don't say K360, we say K180. And then we can say K is an element of Z. And that is literally your answers, guys, up to there. Here we are given an identity, and the first question says, prove the identity, but it's only for 3 marks. Okay, so I'm going to quickly write it down. Now, although this one's only for 3 marks, it's actually quite challenging because there's a lot that we could try to do. For example, you've probably come across examples. I've definitely done examples like this before in my previous videos, where whenever there's a 3, then we would typically change that to 2x plus x. But we have so many of these 3x's around that you would have to do so much work, and it would only be worth 3 marks. So there has to be something else. So what I'm going to do is we're going to work on the left-hand side, okay? We're going to work on the left-hand side. So let's just say here, left-hand side. Okay, let's make this a bit easier. Let's just say here, and let's just say left-hand side. Now, there is a mathematical trick that I would encourage you to do whenever you are in a situation like this, where it just doesn't seem that we would have to change 3x into x plus 2x for both of these, because that wouldn't even make sense, because then, just look here, it doesn't make sense, because if you change this to x plus 2x, okay, and you change this one to x plus 2x, you can then go do whatever you want, and it's going to take a lot of time. At the end of the day, it's not going to end up looking like this, because this one still has 3x's involved, and these ones are going to be changed from 3x to something else. And so these two sides would never look the same, unless you also came and did it on these two sides as well, but that's never going to be only worth 3 marks. So in a situation like this, what you do is you do a little trick. You multiply this left side, for example, by the reciprocal of this number. The reciprocal meaning, change it to 1 plus. Multiplied by the conjugate of the denominator. So let me write that down. Multiply by conjugate of the denominator. Conjugate is where you change the sign in between them, and you do that at the top and the bottom. I'll explain why now. So 1 plus cos 3x. At the bottom, 1 plus cos 3x. What is 1 plus cos 3x divided by 1 plus cos 3x? Well, it's 1. So we're technically multiplying our question by 1. So we're not really changing it mathematically, but we're just doing a little bit of a trick. Okay, so this is a multiply. So the top part, we're just going to multiply. You can either multiply together, like put the brackets and all of that, or I'm just going to leave it like that. Okay, let's just write this next to each other. Like that. At the bottom, I'm going to go multiply this out. So let's put these two brackets together. Okay, so that's going to give us sin 3x, 1 plus cos 3x. At the bottom, you're going to end up with 1 plus cos 3x minus cos 3x minus cos squared of 3x. Okay, see that this part here is going to cancel. And so you're just going to be left with sin 3x and then 1 plus cos 3x. And then at the bottom, 1 minus cos squared of 3x. Now, remember the grade 11 formula that told us that sin squared plus cos squared is equal to 1. But that doesn't only mean it works when you have x. That could be anything. So you could change this to 4x. Then this would change to 4x. As long as these two angles are the same, that identity works. So let's change that identity to 3x. Okay. And then I want us to get, let's quickly get this by itself. So what would that give you? Sin squared of 3x is equal to 1 minus the cos squared of 3x. And that is exactly what we have over here. So what that means is that we could replace this with this. Okay, so I'm going to take this away and then just replace it with sin squared of 3x. Now here we have a sin 3x and here we have a sin squared 3x. You could think of sin squared as sin 3x and another sin 3x, right? That's the same thing. So we could cancel one of those, and then you're left with 1 plus cos 3x over sin 3x. And that's exactly what the right-hand side is. And so therefore, the left-hand side is equal to the right-hand side. Drop the mic. Kevin exits the building. And then awkwardly returns because he realizes there's a second question. Hey guys, hope you're well. So this next one says, determine the values of x over the following interval. Don't worry about that. We'll look at that a little bit later. For which the identity will be undefined. Okay, undefined is whenever you have, okay, so these are the things we know about undefined. It's whenever you have a denominator that is equal to 0. It's also whenever you have a tan that is equal to 90 degrees or 270, or any multiple actually of 90 plus any multiple of 180. So what do I mean by that? If you have a tan graph, we know that at 90 there's an asymptote. That means undefined. And then every 180 degrees after that, so if you plus 180, there's just going to keep being these undefined asymptotes. Okay? But we don't need to worry too much about that one because there's no tan over here. So what we're going to use is just this one over here, denominator equal to 0. So we're going to have to use both denominators. So we're going to say 1 minus cos 3x. We're going to make that equal to 0. Then we're also going to use sin 3x equals to 0. Okay, so I'm going to take this cos 3x over, well actually I'm going to leave it on the left. Don't want to cause any confusion. And I'm going to take the 1 to the right. I'm then going to divide both sides by -1. So that'll give us that. Now remember, if you've watched any of my lessons before, whenever you have a cos, sin, or tan equal to either a 1, a 0, or a -1, I've always recommended that you don't need to use the reference method. You can if you want to, but I always recommend using a graph. So we're going to go draw a cos graph because we're busy with cos. Why would we do a graph? Well, because. Get it? Because it says cos, so because. Wow, that was bad. Okay, so moving on. So if you have a cos graph, sometimes I make myself really cringe, like my own jokes cringe me out. Okay, so we know that that's a cos graph. Okay, now they're saying this cos graph is equal to 1. So where is a cos graph equal to 1? Well, it's equal to 1 right at the beginning. So at 0 degrees. And then where does it happen again? Well, it happens again over here at 360. And then if you had to keep drawing, it would actually just keep repeating every 360 degrees. Can you see that? So what we can do is we can say that it's whenever the angle, which is 3x, it's whenever that is equal to 0 degrees, or if you add any multiple of 360. So it's saying this one, and then you can plus any multiple of 360. K is an element of z. Then divide by 3 to get x alone. So that's just going to give you k times 120. K is an element of z. That is called the general solution, but they've asked us for a specific interval. But don't worry, we'll go work on that just now. Let's first go finish this one. So here, once again, we have a sin or cos or tan equal to a 0, 1, or -1. So I would recommend just drawing the graph. Okay, just a normal sin graph. I know this is a sin 3x, but you're just going to draw a normal sin graph. Now, where is sin equal to 0? Well, it's here at the very beginning. And then how often does this one repeat? Well, this is actually going to be at 180, 360, and then it would repeat. It would carry on repeating every 180 degrees. So the way that you would answer that, you would say that the angle, which is 3x, it's whenever that angle is equal to at 0 degrees, and then every multiple of 180. That's when the sin graph is equal to 0. Once again, you're going to go divide everything by 3, so you're going to end up with x equals to k times 60, and then k is an element of z. Okay, up till now, we have only done the general solution, but they want the specific solution. Okay, so this is where you're going to go have fun, and you're just going to go plug in random numbers for k. You can plug in numbers like 0, 1, 2, whatever. So, and you want to see that the answer fits inside there. So I'm going to start with this one, and I'm going to let k equal to 1. If you let k equal to 1, you're going to end up with 1 multiplied by 120, which is 120 degrees. Not allowed, because it only has to go between 0 and 60. Okay, so then I'll let k equal to 0. So then x would be equal to 0 multiplied by 120, which is 0. Is 0 allowed? Yes, it is. Okay, so that's our first answer. Now, with this one, and of course over here you could also use negative k values, but then your answer is just going to be negative, and that they don't want that. So then I'm going to move on to this one now. So I'll start by letting k equal to 0. and that'll just give us x equals to 0 times 60, which is just 0. Okay, that's already an answer. We've already got that one. I'm then going to let k equal to 1, and that'll give us 60. And that's perfect because they said we can include 60. I'm not going to go any further because any other number is just going to give us an answer that falls outside of this range. And so the two answers would be 0 and 60. So we're just going to say x equals to 0 or x equals to 60. Without using a calculator, simplify the following expression. Okay, so this is sin 10. So okay, so let me explain. You know, on a cast diagram, we've got 180 minus theta, 180 plus theta, and 360 minus theta. So any angle that is less than 90 would be here. If it's here, you do not do anything with it. So for example, that one, you don't need to do anything. This one, we're going to have to do something because it is more than 90. And then this one we're going to have to reduce, but luckily it's over there. And then we might have to do something with that. Okay, but this sin 10, you just leave it alone. Okay, with cos 440, if you've watched me explain trigonometry before, what I've always said is that if this angle is not on this cast diagram, like if it's not smaller than 360, then you need to modify it. What are we allowed to do? You're either allowed to add 360 or subtract 360. With this one, we are going to subtract 360. So that's going to become cos of 80. Okay, this part here is on the cast diagram, which is really good. So you could just say that becomes tan theta, but tan is negative in this quadrant. Remember, this is a cos quadrant, this is a tan quadrant, this is a sin quadrant. So tan is negative here, so you must put a little negative over there. And then I don't yet know what we should do with this, so let's just leave that for now. Right. Whenever we see two angles that add up to 90, and one of them is a sin and one of them is a cos, then you need to remember co-functions, and you need to remember some things like this. For example, sin of 20 can always be changed to cos 70, for example. Or maybe you have like cos of 30, then that can always change to sin of 60. So cos becomes sin becomes cos, then you just add up the angles to make 90. So this becomes, we can change that one to cos 80, and then the bottom one we can just leave it as cos 80, and then you see those are going to cancel out a little bit later. Here we have a plus and a minus next to each other. Okay, and then there. Now, typically, okay, well, these are going to cancel. They're just going to become 1, so that's 1. Now, I don't like the fact that we have a theta and a 2 theta, so we need to change this. Because some of you might say, yeah, but Kevin, let's just change this to sin over cos. Okay, there's nothing wrong with that. But then there's still nothing you can do here because you cannot mix a theta and a 2 theta together. Mathematically, they cannot go. So let's keep this as tan theta for now. We might have to change it a bit later, but let's think of this as a double angle. You know, on the formula sheet, we have our double angle, which tells us the following. Okay, so let's go change it to that. Okay, now this 2 can slide to the front of this expression because this is one term. So you could write it like this. Okay, now let's go do what you guys suggested at first. I'm not saying you guys did suggest, but for those that thought of it, we can change it to sin theta over cos theta times by sin theta times by cos theta. Now remember, this 2 is not saying that there's 2 of these sins. No, that 2 is just chilling in the front by itself. So, you see how we have a cos theta at the bottom and a cos theta at the top? That means they can cancel. So here I'm just going to cancel them out. I'm just going to write it over here. And so now we end up with 1 minus 2 sin theta and then another sin theta. So sin theta multiplied by sin theta is just going to be sin squared theta. Now this is from grade 12. If you look on your formula sheet, you've got these. And this is why I would recommend that you take these formulas and literally stick them up in your bedroom or wherever and look at them every single day for like 30 seconds to a minute. And it'll ingrain into your head so that suddenly when you're in an exam, you would see this and you'd be like, oh, that looks familiar. Instead of always having to look on your formula sheet and seeing what you can find, become familiar with it. Like when I saw that now, immediately my brain was like, oh, but that's something on the formula sheet. And so just maybe do that. Maybe pause right now, go get these, write them out, and stick them on your wall. And just become used to them. I would also recommend you do all the compound formulas. You know, the ones that are like sin of alpha plus beta. There's 4 of those. I would do those. And then I'd also do the double angle for sin. You know, the one that goes sin 2 theta equals to 2 sin theta cos theta. I'm not saying memorize it, but I'm just saying you look at them every day, and so your brain would become used to what they look like. And so when you see this in an exam, it'll trigger and you'll be like, oh, that is something. And then you go look on your formula sheet. As I said, instead of looking at your formula sheet but having no idea what you're looking for. Okay, so because that's overwhelming, right? So here we go. This is this. So we can change it back to cos 2 theta. And so that'll be the final part of this question where we change it to cos 2 theta. And that is the final answer. They asked us to take this and turn it into one term. Given this expression, it says calculate the value of k if that expression over there is equal to k cos 2x. Okay, now if you look at that and it seems a bit overwhelming, yeah, don't worry. When I look at it, I'm also like, okay, that looks weird. But let's just go start, okay? So I wouldn't worry about that part right now. Okay, so immediately I think what I would do here is I would just think of this as a compound angle. Now, I'm not saying that that's correct. We might start with that and it might not end up being correct. Remember, I never do these questions before I record them. So like, I don't know. I really do not know. I have not looked at the memo. I don't like looking at memos unless I have already finished the question. So we're going to try that, okay? I think it could be a compound formula. So it's these ones that I've just added down here, okay? So this one is this one over here. So that's going to become sin 60 cos 2x plus cos 60 sin 2x, okay? And then this one is just going to be this one. And usually stuff's going to cancel now. Check this out. Sin 60, because this one's a plus and this one's a minus. That's why I thought about this. I want stuff to cancel because this is just too long. I need it to simplify. And so that's going to become sin 60 cos 2x minus cos 60 sin 2x. Now, you see this part here and this part here, they are exactly the same, but the one is a positive and the one is a negative. So those parts are going to cancel. And then you see this part and this part, they are the same, but they're being plussed together. So we will be left with 2 of those. So we can say 2 sin 60 cos 2x, okay? And that's all that we have right now. Now, sin 60, from our special angles, we know that that is square root 3 over 2. So we can change this to 2 square root 3 over 2 multiplied by cos 2x. Now these 2's are going to cancel, and so we're just left with square root 3 cos 2x. Now let's not lose sight of what they actually wanted us to do. They said that this expression, which is also this expression, is equal to that. So we've just simplified all of this now into square root 3 cos 2x, and they said that that's the same as k cos 2x. So we can say that this part is the same, and so then we can just say that this part and this part must be the same. So therefore, k must be square root 3. Now, let's move on to this question. It says that if cos x is equal to that, without using a calculator, determine the value of that. Okay, that's just a special angle that we'll use over there. And then this, and this. Now we know that this part over here, we know from over here that that was equal to k cos 2x. So what we're going to do is we're just going to rewrite this as tan 60, and we're going to change all of this into k cos 2x. Okay, but we also know that k is square root 3. Okay, so there we have that. Now, tan 60 is just square root 3. Okay, you need to know those from your special triangles. So we're just going to say square root 3, and then this is also square root 3 cos 2x. Now square root 3 multiplied by square root 3 just becomes square root 9, because remember, if you say square root a multiplied by square root b, then that's square root ab. But then square root 9 is 3, so this just becomes 3 cos 2x. Okay, so that's what we've got in this expression down to. And they've told us that cos x is equal to square root t. But we don't have cos x, we have cos 2x. And no, you cannot take that 2 out as a common factor. Guys, you've got to be very careful. I've seen a lot of learners who do that. You can never take out a common factor from the angle when in trigonometry. Okay? What you rather do is you look at your formula sheet and you change this cos 2x. Now, I wouldn't change it to this one. Why? Because then you've got a random little sin. I wouldn't change it to this one because then you've got sin. I would change it to this one because then you've only got cos, and they're talking about cos. Okay, so what we can then do is change this to 3, and then the cos 2x is going to change to this, 2 cos squared x. You see here it's 2 alpha, but here it's just alpha. So here it was 2x, but now it just becomes x minus 1. I'm going to multiply that 3 in, so that becomes 6 cos squared x, take away 3. Now, we know that cos x is square root t. So what would cos squared x be? Well, you square both sides. So the square of that square root would cancel out the t. Would cancel out the square root, and so you're just left with t. So we can then say 6, and then we can change this to a t minus 3. With this question, there will be more questions on the next slide. So here we've got 2 questions, and then we've got another one and another one. So in the diagram below, we have the graph of a half cos x. Okay, so it's just a normal cos graph so that's a normal cos graph over there. Okay, and then we've got a sin graph that has been moved 30 degrees to the right. And so a sin graph normally starts here at 0 and goes up, but now it starts at 30 degrees. Okay, so it's just a sin graph that has moved to the right. So this graph is this one. And then this graph is this one. Alright, so it says determine the length of AB. Well, this is 0 and a half. And then this one has an x value of 0 and a y value of negative a half. And so we can just go write those coordinates down. So A is 0 and a half, and then B is 0 and negative a half. And so if you wanted to write down the length of AB, you just take the top minus the bottom. So a half take away negative a half ends up becoming a half plus a half, which is 1. The next question says write down the range of this. So let's quickly talk about range. Range is the y values. So let's just ignore the 3 and let's ignore the 2 for now, okay? And let's just go to the graph of f, which is the yellow one. What is its range at the moment? So its lowest value is negative a half, and its highest value is a half. So that is the range at the moment. So the highest value is a half, and the lowest value is negative a half. So let's just see what the highest value will become after you do this. So you could say 3 times a half plus 2. What does that become? Well, that becomes 7 over 2. And then what does this lowest point become? Well, that's negative a half plus 2. And so that's also, that's a half. And so that would be your lowest and your highest value. So the way that you would write that would be y is an element. So you could either use interval or set builder. I'll show you both. Always start at the lowest value and then go to the highest value. We are including both because, remember, the graph touches its endpoints. Okay? And then if you want to use set builder, you would say y is bigger than or equal to a half and then smaller than or equal to 7/2. So what they're asking for is where is the y value of g minus the y value of f a positive number, and that number over there. So the first thing I want you to realize is that this graph has to be on top because it needs to have a larger y value than this one so that this can be a positive. Does that make sense? G has to be on top. So where is G, which is the green one, on top? It's only in this area over here. So don't waste your time looking over here, because in this area, which graph is on top? Well, the yellow one is on top. And so it would have a larger y value than this one. So you would never be able to subtract them and get a positive answer. Okay, you might just have to think about that, what I'm saying. But it's going to be somewhere over here. Somewhere over here. So we want the distance, the vertical distance between them, to be that. Let me explain again. Let's say you have a graph like this, and then you have another graph like that. If this graph has a y value here of 7, and this graph here has a y value of 3, then then let's say this is g, and let's say this is f. Then if you say g minus f, that's the same as saying 7 minus 3, which is 4. So we want that vertical distance to be 4. You see that? Well, that vertical distance is 4. So we want this vertical distance now to be square root 3/2, which is approximately, it's about 0.87. Okay, so it's not going to be here, because here the y value is 1, and this y value is like -1/4. So that vertical distance would be 1.25 or 1 1/4. So it's not that. So it could be here, if you look carefully. Here the y value is 0. And what's the y value here? Well, if this is 1, see that's 1. This is 0.5. Then this seems to be about right. It's about it's probably around 0.87. So let's go with that one. So you would say the value of x, so the value of x would be 90. It's always going to be a nice number. It's not going to be like 111,7. So that's why I know that this is the correct answer, because it's a nice, easy one to read off. This question says, for which value of x in the interval between -90 and 240, well, that's pretty much the whole graph, will this times this be positive? Okay, now these questions do make learners feel a bit anxious, but let me try to show you that it's quite easy. So you see how they're saying f of x times g of x is a positive number. Now, so they want f of x multiplied by g of x to be positive. Okay, so what you do is the following. So go make a little table that says f of x, then g of x, and then f of x multiplied by g of x. So now I want us to look at all the different scenarios you could have. You could have a place where f of x is positive and g of x is negative, or f of x is positive and g of x is positive, or maybe f of x is negative and g of x is negative, or f of x is negative and g of x is positive. Those are the 4 scenarios that you could have. Okay, now if it was, let's just draw a little table here. Okay, no, that's just going to make it messy. If you had a positive multiplied by a negative, what would that give you? That would give you a negative. If you had a positive multiplied by a positive, that would give you a positive. And if you had a negative multiplied by a negative, that would make a positive. And if you had a negative multiplied by a positive, that would give you a negative. Now they want us to multiply these two together and get an answer that is bigger than 0. Bigger than 0 means positive. So we want this one and this one. So we want this scenario and that scenario. So I'm going to scratch out all other scenarios. It's too overwhelming. So what that means is that we need to go find places on the graph where, let's look at scenario 1 first, and then we'll look at scenario 2 a little bit later. So let's scratch that out. So we're going to go look at scenario 1. Scenario 1 is when f of x is positive. What does f of x mean? It's the y values, remember that. So we're going to look where the y values of f are positive and the y values of g are also positive at the same time, okay? So let's quickly scratch this off. So I'm going to start with the graph of g, which is this one. Where are its y values positive? I'm going to go highlight that. It's only there, right? Now, well, let's start with f actually, because f is the first one on our graph. So let's start with f. So where is f positive? Well, f is positive there. Remember, positive y values, okay? It's not anywhere underneath because those are negative y values. Now, remember we want f and g to be positive at the same time. So let's go see where g is positive. Well, g is positive here. So is there a place where there is some type of overlap? Well, yes. Can you see this area over here? Both graphs are positive. Can you see that? In that area, the green and the yellow are both positive. So that'll be our first answer, from 30 degrees up to 90 degrees. So we can say, if you want to use interval notation, we'd say from, and we're not going to include because they didn't include. So we're going to say from 30 up to 90. If you wanted to use set builder, you would say x is bigger than 30, but smaller than 90. Now we're not done, because that's only scenario number 1. Now we're going to go look at scenario number 2. Okay, so I'm going to take all of that away. Scenario 2 says that the graph of f must be negative. Okay, so graph f must be negative. Negative means under, because it's the y values, not the x values. Okay, so that's where graph f is negative. And then graph g, where is that negative? Well, that's here. And that's also over here. So can you find any overlap? Well, the overlap is here. That's where the overlap is. Okay? So now here you've got to be very careful. So we're going to say that it's, so we're going to say or. Now we're going to go from 210. Now, the 240 is going to be included. Why? Now this is going to confuse some learners, but that's okay because this is a bit of a confusing one. So if you're feeling confused, there's nothing wrong with you. This is a weird one. They don't want you to multiply them, and then they don't want it to be equal to 0. Okay? You see, so for example, at the 90, you can't include it. You know, when we did the earlier part, we did 90. Okay, no, that's not a good example. Okay, here, at the 210, you cannot include the 210 because you see the green graph? What is the green graph equal to at 210? Well, that's equal to 0, and we don't want any zeros. But if you look at the 240, not one of those graphs is at 0. Not one of the graphs has reached the 0 position. Can you see that? This one is still there at like negative 0.25. And this one is at negative 1. So they're not touching the 0 position. They're not touching the x-axis. So their y values are not 0. So at 240, we can actually include that value because it's not going to give you a 0. They just don't want it to be equal to 0. Okay, I hope that part makes sense. For example, the y value of g is negative 0.25 and the y value of f is negative 1. So if you had to multiply those two, you would end up with 0.25, which is bigger than 0. It's not, we can include the 240, okay? So I hope that part makes sense. If not, it's not a huge problem. Like, you literally, if you put a round bracket here, you may be going to lose like 1 mark, okay? And if you prefer interval notation, you would say x is bigger than 210, but then smaller and equal to 240. This next question is very interesting. So it would have caused a lot of confusion for learners who would have done this in an exam paper, for example. So I'm glad you're seeing this. So we need to look at it carefully. So they're saying that it's g with a little line and then x minus 5. Let's ignore the x minus 5 for now. Let's look at that. What does that mean? That means first derivative. Now, what does first derivative actually stand for? Gradient. Okay, so they want to know where the gradient of graph G, now graph G is the sin graph, which is this one that I've highlighted in green. So they want to know where is that graph's gradient bigger than 0. So that means a positive gradient. Now, how do we know what is a positive gradient and what is a negative gradient? Well, a positive gradient goes up when you're moving from left to right. That's a positive gradient. A negative gradient goes down. So what we're going to look at now is we're going to look on this graph, okay? And we're going to see where is it having a positive gradient. Well, we can see that over here, the gradient is negative, okay? You can see that it's going downhill. We need to find places where it's going uphill. So that would be this area over here, okay? You can see that it's going up over there. So that would be from this turning point up to this turning point. Yeah, but Kevin, what about the x minus 5? Don't worry, we're gonna add that in now. That's an easy part. We'll just add that in at the end. Okay, so I'm gonna quickly take this all away so we can just see nicely what these values are. So it's at that turning point there, and it is at that turning point over there. So you would maybe want to, like, if there wasn't an x minus 5, then you would say that the answer is negative 60. Obviously, I'd write it in a better way, like interval notation or set builder, up to 120. Now, what we can quickly do is just incorporate this part. What does that do to a graph? Remember, when it's a x, or when it's in the bracket like that, it's horizontal, okay? And when it's a minus, it means to the right. So the graph is shifted one place to the right. So instead of this part being, not one place. So the graph is shifted 5 units to the right. So instead of it being here at negative 60, it's going to be 5 units to the right. So it'd probably be there at negative 55. And then instead of it being there, it'll be shifted 5 units to the right at 125. And so now we can write our answer. So if you prefer interval notation, you would say that x is an element going from negative 55. I'm not going to include the value because they didn't include it. And we're going to go all the way up to 125. Okay. If you prefer set builder notation, then you would say x is bigger than negative 55 and smaller than 125. With this question, it will carry on onto the next slide. So here's the first part, and then we have a second and a third part. Okay, so it says figure 1, which is this one over here, shows a ramp leading to the entrance of a building. B, C, and D lie on the same horizontal plane. Okay, so B, C, and D are on the floor. Okay, so you must remember that. They are like on the floor. Some learners do struggle to visualize 3D. But it's a ramp leading up to a building. Okay, so maybe we've got some type of building over here with windows, and there's a door, and this ramp is going to there. Okay, and then people park their car over here. See, there's your car. Okay, I'm terrible at drawing, but there's all the cars that are parked there. It's a matric dance, and then all the people are walking up the ramp. Here's the red carpet, literally. Because it's red. And then, but that is why it's called a red carpet anyways. Okay, so that wasn't actually a pun. Okay, that was so stupid. So, okay, so there it is. Yeah, hope that makes sense. I don't know where I was going with that. Let's actually just carry on with the rest of the question, Kev. Maybe that'll be a good idea. Okay, so figure 1 shows a ramp leading to the entrance of a building. B, C, and D lie on the same horizontal plane. Okay, so those are on the floor. The perpendicular height AC is 0.5 and the angle of elevation is 15 degrees. The entrance of the building AE is 0.915 meters. Okay, so everything that they've said is is shown on the diagram. First question for only 2 marks. Calculate the length of AB. Now, to work out AB, you're just going to work in this triangle over here. Now, remember, this triangle is a 90-degree triangle, so you can use your grade 10 formulas. You remember SOHCAHTOA. You don't have to. You can use the grade 11 formulas. I find that a lot of grade 11s and 12s, once they pass grade 10 or they get out of grade 10, they just forget about those SOHCAHTOA formulas. But I find it sad. Well, not really. I don't like really find it sad, but I find it interesting because these formulas are much faster than the grade 11 and 12 ones. But yeah, I think just try to remind yourself that if it's a 90-degree triangle, you are allowed to use this. However, if you feel like using the grade 11 ones only, you know, the sin rule and the cos rule, you can also use those on a 90-degree triangle. So it's not like you'd be wrong, it just takes a little bit longer. All right, let's move on. Okay, so we're going to use SOHCAHTOA. I'm going to force you to go back to grade 10. So what we do is we take any angle that we have, which is this one over here, and we are looking for the length of AB. So that's called our hypotenuse. What do we have? We already have this one, which is called your opposite. So we have the opposite and the hypotenuse. Well, we're looking for the hypotenuse. So that's O and H. So that means we're going to use sin, because sin uses O and H. So we can then say that the sin of which angle? 15 degrees. Whoops, I don't know why I'm saying a little dot there. Sin 15 is equal to the opposite. Opposite is AC over the hypotenuse, which is AB. So we can say sin 15 is then equal to AC, which is 0,5 over AB. Now, there are some learners who still struggle with what to do in this situation. So let me just write it over here. So remember, what you got to do is you have to take this AB to the left. So you multiply, so it becomes AB sin 15. And then on the other side, you have 0,5. Then you have to divide by sin 15. So you end up with 0,5 over sin 15. And so if you had to go work this out, you end up with 1.93, and then just stick to their units, which is meters. So this one says, okay, so it's the same scenario. This one says figure 2 shows the top view of the ramp. Oh, okay, so remember in the previous question, we had, this is the ramp. This is just the top view, okay? So technically, we've worked out this length of AB, which was 1.93 meters. So in case we need it over here, 1.93 meters. Okay, some of you might be like, yeah, but bro, wasn't this meant to be 90 degrees from the previous question? Like, didn't they say that that's 90? But remember, this is 90. What you're looking at over here at this top view is this angle, okay? So that, I hope that makes sense. So the 90... it's not this one. Okay, so figure 2 shows the top view of the ramp. The area of the top of the ramp is divided into 3 triangles. 1, 2, 3. Okay, good. As shown in the diagram, if the angle BAE is 120, BAE is 120, as they're showing already, calculate the length of BE, and it's only for 3 marks. Now, first question I have for you, is this triangle a 90 degree? No, it is not. So now you cannot use the grade 10 formulas of SOHCAHTOA. Not allowed. Now you are limited to the grade 11 formulas, which are A over sin A equals to B over sin B. Now I know there's also a third part which says C over sin C, but yeah, not going to use that right now. So you could either use that one, well, sometimes only one of them works, and then this one, C squared plus A squared, I don't know what I just said. C squared is equal to A squared plus B squared minus 2AB cos of angle C. Right. So I always tell learners, look, learners, these are only 2 that you need to use. So just try this one first. If it doesn't work, then use this one, okay? So I know for a fact this one's not going to work. I'll show you why. We have this angle, okay? So we have, for example, that angle. Do we have the side opposite that angle? Well, that's the side that we're looking for, which is BE. Okay, so that would go up here. And then do we have another side? Yes, we do. It's over there. So we have this one. But we don't have the angle that is opposite that one. So we wouldn't have this angle. So how many unknowns are there? Well, we don't have this, and we don't have that. 2 unknowns, impossible to solve mathematically using only one formula. But Kev, my bro, can't we just do like simultaneous? Yeah, okay, so I hear you. But remember, there's going to be a better way. So in this section, we're not going to do simultaneous with things like that. We're rather just going to use a different formula, okay, a different setup. So the way that this formula works over here is you need an angle, okay? So here's the angle that we can use. Then you see this C goes with this C. So what I'm trying to say is that if this angle is 120, then this C is the side opposite that angle. So opposite that would be BE. Okay, so we can say BE. Well, let me first show you that we only have one unknown. So that's going to be BE. Then the A and the B are the other two sides. The other two sides, this one and this one. It doesn't matter which one's A and which one's B. And you see, so we have AB and we have AB. So the only unknown is this one. Okay. So now we can just go fill everything in. So we know that this is BE squared. Then A, it doesn't matter which one's which. So you can say 1.93 for this one, and then just use 0.915 for the other, squared, and then 1.93, and then 0.915, and then cos, and then the angle is 120. Okay, go ahead, type all of the right-hand side stuff onto your calculator. And so you should end up with BE squared equals to, it's like a 6.328 value, but then we take the square root to get BE alone. And to 2 decimal places, it'll be 2.52, and then that would be measured in meters. So this question says, calculate the area of triangle BFD. Okay, so that's F over there. So it's triangle BFD, so there it is over there. And then they tell us that BF is equal to FD, but we can see that they've shown us that already. And then they tell us that BF is 5/7 of the length of BE. Okay, so step one is let's go use this information. So we can say that BF is 5/7 of the length of BE, which we worked out in the previous question as 2.52 meters. And so, it works out beautifully. 1.8. So that means the length of, now I doubt we'll need that part again. So the length of BF is now 1.8. But that means that the length of FD is also 1.8. So we can say, I doubt we'd have to say this, but let's just say FD is 1.8. Or let's just say FD is equal to BF, and that information was given to us. Therefore, FD is 1.8 meters. Okay, so we can go fill that in. And now they want the area. So so for area, there's two formulas. Half base times height, and then half AB, half AB sin C. Use this one if you have a 90, like if you know the perpendicular height of the triangle. So the perpendicular height would be like that height over there. We definitely don't know that, so we're not going to use this one. How does this formula work? Well, this formula works like this. You need a triangle, obviously, Kevin. Don't be stating obvious facts, bro. So we need a triangle, and we need a angle, okay? If you have that, then you need the two sides next to the angle, so A and B. So it almost looks like the cos rule. And some learners get a bit confused with this because they're like, yeah, but this is sin, so why are we using the same thing as cos? But remember, we have three different formulas. We've got A over sin A. Okay, that's called the sin rule. And then we've got the C squared equals to A squared plus B squared minus 2AB cos C. This is called the cos rule. Now, it just so happens that the setup that you use for this one is the same as the setup you use for this one. Okay? This sin rule is a totally different one. Okay, this is actually called the area rule anyways. Okay, so the way it works is then we're going to use this angle and then the two sides next to the angle. So it's perfect. So we're going to go half and then 1.8 and then 1.8. Remember, A and B are just the two sides next to the angle. Doesn't matter which one's first. And then you're going to say sin of 75. And so if you work this out, then to two decimal places, you're going to say 1.56. And then m, because it's meters, and then squared, because it's area. So with this question, it will carry on. So here we've got our first part, and then it moves on to extra questions after this. So it says that in the diagram, DEFG, so where are you? DEFG, DEFG is a cyclic quadrilateral. They tell us that DE is parallel to GF. Okay. DE is produced to R. T is another point. E, G, F, T are drawn. Some of the stuff that they say is really weird. Like, of course, EG is drawn. Of course, ET was drawn. What else would it have been? Anyways, E4 is equal to 72. And then G1 is equal to 16. Okay, so the first question says, determine the size for 2 marks, DGF, DGF. So DGF. Okay, so that is this whole angle. So remember, now I'll show you a mistake a lot of learners will make. A lot of learners will say that this 72 is the same as angle G2, and they'll say tan chord theorem. But remember, this is not a tangent. A tangent has to be on the outside of the circle. Okay, so if we have the cyclic quad, which they told us earlier, and we know it's a cyclic quad anyways because E, F, D, and G are on the circle, and that's 4 points. So we know from a cyclic quad that it's got some properties. One of those properties is that the angle on the outside is equal to the inside angle that is opposite. So what does opposite mean? Well, is this opposite? No. Is this opposite? No. It's the other one. It's the one in between those two. It's this angle here. So the cyclic quad, one of the properties is that these two angles are the same. So if you look at the cyclic quad, this is the outside angle, and this would be the opposite side. Okay? And so this whole angle here is the same as this whole angle here. So we could say that the answer is 72 degrees, 72 degrees, and the reason will be exterior angle of a cyclic quad. So we can then say that angle DGF is equal to angle E4, which is 72 degrees, and the reason is because it is the exterior angle of a cyclic quad. So from the previous question, we know that this is 72. So I'm just going to fill in G2. So G2, which is this one over here, would obviously just be 72 take away 16, which is 56 degrees. So I'm rather going to fill that in as 56. So I'm going to take that out, and I'm just going to do that. Okay, so this question says, determine for 2 marks the size of angle T. Here's angle T. Okay, so you see, straight away I see as you practice this stuff, your eyes begin to just see it. Look at this. Can you see the bow tie? See that? Ah. So when you see a bow tie, the top, those 2 angles are the same, and then those 2 angles are the same. Okay? And to make double sure, you see this angle, it comes from this point over here. So if you extend those lines, let's see where it ends. Okay, it goes to F and it goes to E. Now if I do the same with this angle T, it should get to the same place, to E and to F. You see it went to the same place, so we know that they're both coming from the same place, so it definitely is a bow tie. So what we can then say is that angle T is going to be 56 degrees, and that is because of angles in the same segment. Okay, you can just say seg like that. This question for 2 marks says, determine the angle GEF. GEF, where are you? GEF, okay, so G, E, and then F. Okay, so it's this angle over here. So let's take away those lines. So it's this angle here that we are looking for. So straight away, my eyes were caught onto these parallel lines. So because of those parallel lines, I know that alternating angles would tell us that E1 is going to be 56 degrees because of alternating angles. So you could say alt angles. And then which lines are parallel? DE is parallel to GF. Okay, now we could possibly look at this straight line over here, and we know that this is 56, so we could say 180 minus 72 minus 56, because we know that all of these angles must add up to 180. So we could then say that angle GEF is going to be 180 minus 56 minus 72, and this is because of angles on straight line. And so if you had to work out this angle, GEF, it would be 52 degrees. So with this question, it will carry on onto the next page. Okay, so here's our first question. So it says, in the diagram, the diagonals of the parallelogram KLMN, okay, so that's a parallelogram, KLMN, all right, intersect at P, NM is produced to S. Obviously, I don't know why they say certain things, like obviously NM is produced to S. Okay, I guess they just have to make it clear, but I mean, it's very, okay. R is a point on KL, R is a point on KL, and RS cuts PL. Yes, we can see all of that, thank you. Here we go, this is important. NM to MS. Okay, so they're saying that the length of NM to MS is 4 to 1. They're not saying the length is 4 and the length is 1. They're saying the ratio. So what you'll do then is you'll say that NM is 4x, for example, and then MS will be 1x, okay? But it doesn't mean the length is 4 and the length is 1. It's just ratios, okay? Then NL is 32. So that's an actual value. Okay, so NL is this long one over here, so that's 32, okay? I struggle when they say things like that, like, where do we write 32, bro? Do we write it here? But now we mustn't forget that that's not PT, that's the whole thing over here. Okay, so that's 32. Let's see if we can do it like this. Okay, and then TL is 12. Okay, so we know that that's 12, but we know that this entire part is 32. Okay, so yeah. The first question for 4 marks, determine with reasons the value of the ratio of NP to PT. Okay, NP to PT. Okay, guys, well, let me just show you the basics of this question. So we know they told us that this is a parallelogram, okay? Now, if we think about any parallelogram, let's quickly draw it over here. Whoopsie. Now, we know that parallelograms have diagonal lines. Whoops. There. And there. Now, we know that this length and this length are the same, and this length and this length are the same. Okay, but they're not all the same as each other. For example, these two aren't the same. The diagonals aren't the same length, but they do cut in half. So this part and this part is the same. So what that then means is that if this whole length is 32, then it means that this part is 16. Okay, so we can say there that NP is going to be 32 divided by 2, and that's going to be 16. And that'll actually also be the same as PL. So we can say that NP is going to be equal to PL, right? And they're both going to be 16. There is a reason for that, and that is just to say that it's the diagonals of a parallelogram. That is just the property of the diagonals of a parallelogram. Okay? Wow, they're really whipping out the grade 10 stuff here. Okay, so you don't often see this in a grade 12 paper. Okay, now we know that this whole length is 16, but we already know that TL is 12. So then we can get the length of PT. So the length of PT would just be 16 take away 12, and that's 4. There's no reason for that. That's just, you don't have to give a reason for that one. Okay, so we can just say here 4 units. And here I should have said units. It's not that important. Okay, now we can easily get the ratio because now we have NP and we have PT. So we know that NP to PT is then going to be equal to 16 and 4, and then that can simplify 4 to 1. This question says, prove that KM, so KM is this line, and RS is this line. So prove that they are parallel. Well, check this out, guys. We know that in the section of proportionality, okay, in grade 12 maths, we know that you need parallel lines in the triangle, okay? Now, when those lines are parallel, only when those lines are parallel, then we are allowed to use proportionality, and we can say things like AB over AC is the same as AD over AE. Or we could say, for example, AB over BC is the same as AD over DE, for example. Okay, that's because these lines are parallel. But you can also use this in reverse. For example, what if we don't know that these lines are parallel, but we know, for example, that this is 5, and this is 2, and this is 20, and this is 8. Then if you look at this ratio, that's 5 over 2. 5 over 2. What is this ratio? Well, it's 20 over 8. But if you simplify that, the number 4 goes into here 5 times, and the number 4 goes into here twice. And so look, their ratios are actually the same. So because these ratios are the same, we can then say the reverse and say, because of that, these lines are parallel. You see? So if we look at this triangle, then look at these ratios. So for example, look at NP over PT. Okay, what is that equal to? Well, that's equal to 16 over 4, and that's equal to 4 over 1. Now look at NM over MS. So you could say NM over MS, that's 4x over 1x, which is also equal to 4. So then what we can say is NP over PT is the same as NM over MS. So because of that, therefore, these lines, KM, even though it's KM, it doesn't matter if we're only using this part. We can still say KM because it's all one line, right? So we can say KM is parallel to RS. And then we can say, yeah, the lines are parallel, but now your reason, because we used, you remember how I showed you here, how we just used the proportionality theorem, but we used it backwards. So we're going to have to use the word converse. So we're going to say converse. That means we used it the other way around. You could say converse of prop theorem. That's one way. Or the more popular way that learners like to use, so let's just write that down. You could say prop. You could say converse of prop theorem. That's one way of writing it. And then the other way is that you could say converse of line parallel side, or one side of triangle. Okay, converse of line parallel one side of triangle. So you must just choose whichever one. I use both. I mean, sometimes I'll explain it using this one, and then sometimes I'll use prop theorem, which stands for proportionality theorem. This one says that if NM is 21, okay, so this is 21, determine with reasons the length of RL. Okay, so straight away, remember, this is a parallelogram. What do we know about parallelograms? The opposite sides are equal. So we can say that this length here, we know that that's 21, so that means that this length is also 21. So we can start off by saying that KL is equal to 21, and that's just because of the opposite sides of a parallelogram. Now, we know that these lines are parallel, so we could work inside this triangle here, and we could use the proportionality theorem. So we could say, for example, now be careful here. Well, not be careful, but just be clever to save time. Check this out. We know that we need to find RL. So definitely use RL in your ratio. But now you could say RL over KR, or you could just say RL over KL. Now, I would recommend this one. The reason, we know this length. We know this length is 21. If you went this way and you used KR, it's also correct, but you don't know the length of KR. And so you're going to have more unknowns. So rather use KL, but now you have to match that carefully on the other side. So you see how we used RL. So on the other side, that is TL. Okay. And then you see how we used the whole length. So on the other side, on this other side, you're also going to use the whole length. So that's not PT. Don't use PT, because PT would only be used if you used KR. You are instead going to use PL. Okay? And we need to give a reason for that. So you can either say prop theorem, and then you must mention the lines that are parallel, or the most popular for most students is line parallel, one side. I always forget that. One side of triangle. Now we can just go fill everything in. So RL we don't have. KL is 21. TL is 12. And PL would be 16, right? Okay, and now we just need to, I think what's most, there's easy ways of doing this, but I think what most learners are comfortable with is cross multiplication. So you multiply that there and you multiply that there. Okay, so that becomes 16 RL equals to 21 times 12. Then to get RL alone, you can just divide by 16, and so you end up with that. Okay, so you see that the 16 didn't actually need to go anywhere, but if you're just comfortable with doing cross multiplication and then dividing like we just did, that's okay. Then if you go type that all in on the calculator, you end up with 15.75 units. In this question, they give us two triangles, ABC and DEF. They tell us that angle A and D are the same, and then B and E, and then C and F are the same. Okay, so these are similar triangles because all they have angles that are equal to each other. So it says, use the diagram in the answer book to prove the theorem which states that if two triangles are equiangular, meaning similar, because they've got angles that are the same. So remember, those are the same, those are the same, and those are the same. Okay, so equiangular, equal angles. Then the corresponding sides are in proportion. So for 6 marks, this is actually a proof that you can find in most textbooks. But of course, I'm going to show you and explain exactly how this all works. Okay, so I'm going to first show you exactly how it all works, because that's quite easy. I want you to just get that understanding of, oh, okay, so that's what they're doing. And then I'll show you what to write down, okay? Or maybe I'll just do it all in one step. I think, let me just do it all in one step. So the first thing that you pretty much do, guys, is you take the smaller triangle and you're going to add it in to this triangle over here, okay? But let me show you how it works. So you're going to put, you're going to take this length over here, DE, okay? And you're going to put that length over here, okay? So that length is going to be the same as DE, right? Then, okay, so let me actually explain it. I'll just show you first, and then I'll show you what to write down. Okay, then you're going to take DF, and you're also going to put that on the drawing, so maybe over there. And then, okay, so you've got those two dots now. Now, don't call this E, and don't call this F. What you rather do is just give it other letters, T and R, for example, okay? So let's actually go write it down. So we said that we're going to have to do a construction. And of course, you can look in your textbook or follow what your teacher says, but the idea is that we're going to say, let the point T lie on AB such that this distance is the same as this distance, okay? So such that AT is equal to DE. Then you're just going to repeat that for the other one. So let R lie on AC such that AR is the same length as DF. So you see what we've done, guys? We've just put this length and this length onto this diagram, okay? Then you're going to connect T and R. So you're going to construct, connect TR. Okay, now remember that this length is now the same as this length, and this length is the same as this length, okay? So, do you remember from like grade 9, we had congruency? Congruency is when two triangles are exactly the same, and we had 4 different options: side, 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 angle, side, side, angle, angle, and then RHS, which stands for right angle, hypotenuse, and side. So these two triangles are now going to be exactly the same. And it's for one of these reasons, okay? So what we can then say, or the way we can prove that, is we can say that, well, first what we'll do is we'll show the examiner that the construction part is now done. Now we're moving on to the proof itself. So we can say here, proof Okay, so then we're going to work in triangles. ATR, because remember we want to try to prove that these two are now congruent. In triangle ATR and triangle DEF. Let's write that a bit better. Okay, so we can say that side AT is the same as DE. And that's not because of given, that's because of the construction that we just did. So you can just say construction. And then we can say that AR is the same as DF, and that's also because of a construction. The next thing is that we can say that this angle is the same as this angle, okay? We can't necessarily say that these two are the same. I know it's tempting. They are actually the same, but mathematically we can't say that. But we know that this is the same because we made it that way, okay? And we know that these two are the same because we made it that way. And then we also know that these two angles are the same, but that's because they told us that in the beginning. So we can say that angle A is the same as angle D. Let me write that a little bit better for you guys. So angle A is the same. Oh, Kev, come on, dude. So let's say it here. Angle A is the same as angle D, and that's because of given. Okay, so you can decide, well, you need to make the right choice. Like, which one is it? Well, what we just chose was a side, and an angle. And the angle, if you remember from grade 9, has to be in between the two sides for us to be able to use this one. So you can say, therefore, these two triangles, ATR and DEF, are congruent. Remember, congruent is the three horizontal lines. So you could now say triangle DEF. And the reason is side, angle, side. Or some learners like to say side, angle, side, like that. So what we've just proven is that these two triangles are exactly the same. So because of that, this angle over here is going to be exactly the same as this angle over here, for example. So what we can now do is say that those two angles are the same. So we can say that, and you could have also chosen this one and this one if you wanted to, but you only have to choose one of them. So I'm just going to say angle ATR is the same as angle DEF. And you don't need to give a reason for that. You should actually say here, therefore. Because remember, we said that the two triangles are congruent, and so therefore we can say that that is true. Okay, so I'm going to put a little X here over here now. Now, can you remember from parallel lines and I'm not saying that these lines are parallel, they're not necessarily parallel, but can you remember from like grade 9, we learned about parallel lines, alternating, corresponding, co-interior, for example. Can you remember what these would be? Well, can you see that they're equal? We know that they're equal. So then what type of angles are those? Are they alternating angles, corresponding, or co-interior? Well, those are corresponding. And because they are the same, then that means these two lines have to be parallel. So we can say, therefore, the line TR must be parallel to BC. And that's because the corresponding angles are equal. Okay, so that's where we're at up to now. We now know that those two lines are parallel. So let's just summarize what we've done so far. The first thing we did was we took this triangle over here and we drew it onto this triangle over here. Okay, but we used different letters. Okay, we then knew that this length, we made that length the same as that length, and we made this length the same as that length. We then used grade 9 congruency to show that these two triangles are exactly the same. So because they are exactly the same, it means that this angle and this angle is the same. Okay, but we already knew that these two were the same because they told us that in the very beginning. So if these two are the same and these two are the same, well then we said that these two must be the same. And because these two are the same, well, we know from parallel lines that these two lines have to then be parallel because these two angles are corresponding. That's where we're at so far. You got it? Cool. So let's move on. So because these two lines are now parallel, we can now come into our grade 12 Euclidean geometry and we can start to do the proportionality theorem, because that just needs a triangle with parallel lines. So what we'll do is we'll then say that AT over AB is the same as AR over AC. Right? Now this is grade 12 proportionality. AT over AB is the same as AR over AC. Now some of you might be like, yeah, but Kev, can't we also do AT over TB and AR over RC? You could, but it won't get you anywhere in this proof. Just use the sides that they have here. So they used AB, so we used AB. They used AC, so we use AC. These will come in a little bit later, okay? So here you must just give a reason, prop theorem, or you can say line, parallel, side, one side. I always forget that one. Line, parallel, one side of a triangle, okay? Now we can say, but we know that AT is actually the same as DE, because remember the triangles are congruent, and AR is actually the same length as DF, because those triangles are congruent. So then in the next line, we're just going to replace this with DE, because remember AT is the same as DE. So we can then say DE over AB is then going to be the same as AR, but that's the same as DF, over AC. Now you see how the way we've got it is exactly the upside down version of that, but mathematically you can just switch this around, okay? So moving into the very last line, it doesn't matter if you just switch it around. AB over DE is then going to be the same as AC over DF. And that's what we were trying to prove this whole time. So I would highly suggest, if you didn't understand that 100%, just go watch that again. It's actually really easy, but I remember the first time I looked at it in textbooks and tried to understand it. You don't typically get it the first time. You have to go through it a few times. So I would encourage you, if you didn't get that fully, then watch this again and just take a little piece of paper somewhere, or take a pen and a piece of paper and just draw it out and try to make sense of it for yourself. Because once it clicks, you're going to be like, oh, it's actually super easy. So with this question, it is going to carry on the other slides, okay? So there will be more questions added. So here's the first one, and then there's a second part, a third part, and a fourth part. Okay, so let's begin. In the diagram, O is the center of the circle, okay? So this big circle, it's the center. EC is a tangent. Okay, that's important. EC is a tangent. So let's just remember that one. EC is a tangent. It's also important to know that O is the center. Diameter DB. Okay, we know it's a diameter because it passes through the center of the circle, meets tangent EC at E. F is a point such that BF is perpendicular to EC. BF perpendicular. Okay, they have showed us that already. That's fine. Radius CO produced bisects. Bisects means cut in half. AD at G. Okay, so there's AD, but there's G. But then they've showed us that it bisects because those two are equal. Okay, so everything else has been shown. Excellent. Let's begin. So for 3 marks, the first question says, prove that FB is parallel to CG. So I think straight away what jumped out to me was, when you've got lines like this that you're trying to prove parallel, there could be some type of corresponding angle. So maybe this one and this one is the same, or co-interior, for example, those could be maybe equal to 180. I don't really see any alternating. I mean, there could be an alternating, so that's another option. But what we can realize is that, this here is the center of the circle. So what do we call this line then over here? Well, that line is the radius, okay? Now, we know that that's the radius. And they told us that this line is a tangent. So in a circle, if we have a radius and then we have a tangent. What do we know? Well done if you remember that a tangent and a radius always makes 90 degrees with each other. So we could then say that angle, this big angle here, so that's going to be angle OCF is going to be 90 degrees, and that is because we have a tangent that is perpendicular to a radius. Okay, so that's 90 degrees over there. So then have a look at that, guys. Those two angles are now equal. So we can then say, therefore, FB, the line FB, must be parallel to CG because the corresponding angles are equal. Or let's rather actually say, for this one, you have to say equal like that. If you do it like that, I'm sure it wouldn't be a problem. But FB parallel to CG, and that's because the corresponding angles are equal. Okay, so let's just put in that those two are now parallel, and that's a 90 degree. The next one for 5 marks, okay, it says that prove that this triangle is, now you've got to remember what these 3 lines are. That's similarity, it's not congruency. So prove that triangle that is similar to that. So triangle FCB, so FCB, and then triangle CDB. So CDB. Okay, so we need to prove that these two are similar to each other. So we have to show that all their angles are equal. Okay, so have a look carefully. You can see the 90, right? We know that this one's 90, but we'll have to give a reason why. And then you can see there's a 90, what looks like a 90. So that should guide you to think, is it maybe a 90? Because it definitely looks like this one's 90, and it is, but we need to explain why. So we can start off by saying that angle F2, okay, this one here, we know that that'll be 90. Why? Because these two are on a straight line, okay? So angle F2 is 90 because of angles on a straight line, okay? Now, this angle here is 90 degrees. Why is that? Remember, if you have a circle with a diameter, okay, and if that diameter has any angle that it makes on the circumference, then it's automatically 90 degrees. So here we have a diameter, and so it makes this angle here, and so it must be 90 degrees. So we can say that angle BCD, which is this, sorry, just those two over there, that's 90 degrees because of angles in a semicircle. Okay, so we can say therefore angle F2 is equal to BCD. Okay, so we have one angle that is the same. Excellent. The next one, guys. Whenever you have a tangent, I always want you to think about looking at the tan chord theorem. Oh, really, Kevin? I hate the tan chord theorem. I know, guys, a lot of learners don't like the tan chord theorem, but it's actually awesome. Easy for you to say, Kevin. You do this all day. Guys, trust me. Tan chord theorem, I know it. I've seen learners don't like it, but once you do the tan chord theorem enough, you begin to just see it pretty quickly and pretty easily. So the way it works is that if you have a circle and you have a tangent, ooh, that was a bad tangent. Okay, so there's a tangent, right? Then just draw, then imagine there's a chord. A chord is any line in the circle like that touches the circumference on both sides. Then take the angle that is in between the tangent and the chord. So for example, that angle there. Okay, now let's quickly take that chord and just make another angle. Okay, so the tan chord theorem says that the angle that you make between the tangent and the chord, which is this one, will be equal to the angle that the chord makes in the circle. So you see, here's the chord. Now where is that chord making an angle? Here. And so these two are going to be equal to each other. Okay, so here's your tangent. Now, where's the chord? Well, the chord, there's many chords here. Here's a chord. That's not a chord. A chord has to touch the circumference. That's a chord. So, we're not going to use this one, because if we use that one, and we use this tangent, then what is the angle between them? Well, it's that one. And that angle is useless to us because that angle is not part of any of the triangles. But what if we use this angle? So that's between the tangent and this chord. Okay, so now that means you have to let's actually take away all these colors. My goodness. So let's take that chord now. And then all I want you to do is try to see where does that chord come together. So if you go along here, and if you go along here, then it meets at D2. So we can see that this was the tangent. So this was the tangent. This was the chord. And this was the angle that we used. And we can see that that chord came together here at D2. So that means that D2 and C1 are the same. So we can say that angle C1 is the same as angle D2, and that is because of the tan chord theorem. Okay, so we have now proven two angles that are the same. We proved that these two are the same, and we proved that these two are the same. So remember, with similar triangles, the third angle is the easiest. And so let's just remember what triangles we were busy with here. So it was always FCB and then CDB. So, okay, so we've already used this one and this one. We already used this one and this one. So what haven't we used? Well, we haven't used B2 and we haven't used B3. So we could then say that angle B2 is equal to angle B3, and that's just because of the sum angles triangle. Well, let me write that a little bit better. Sum of angles in triangle. Okay, and so now we can make our conclusion. Therefore, and now here they've already given us the triangles. Triangle FCB is similar to triangle CDB, and that's just going to be because of angle, angle, angle. Okay, remember, similarity is all about angle, 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 instead of congruency, which is like side, angle, side, or side, side, side. Okay, let's move on. So with this next question, it is so important that you, whenever you do similarity, which we did in the previous question, remember we did it here, FCB and CDB, it's important that you just remember that, okay? So I've written that up here for us because I can guarantee they are going to ask us a question after that one, or it's going to be one of the questions after that, where we probably, not always, but it's a very high chance that we're going to have to use this again, okay? So that's important. Then I've also put all the other information so long. So this one's only for 1 mark. It says, give a reason why angle G1, where's G1? G1 is 90. Okay, so this goes all the way back to the very beginning of grade 11 Euclidean geometry. If you have a circle and you have a center and you have a chord, then if you connect that chord to the center of, the center of the circle to the center of the chord, okay, then what that does is it automatically divides, if that's the center, then it automatically makes this angle 90 degrees. Do you remember that from grade 11, the beginning of grade 11? So what we have here is a center that is going to the midpoint of the chord. How do I know it's the midpoint? Well, these two are the same. And so because of that, this angle must be 90 degrees. Okay, so we can just say that it's line from the center. It's because we have the line from the center. Now, what do we have, guys? What did we have? Did we have a line from the center going to the midpoint, or did we have a line from a center going to perpendicular? Well, what we already had was the midpoint. So we can say line from center to the midpoint of the chord. So here comes the next question, and here we go. For 5 marks, prove with reasons that this is equal to that. Okay, so keep this part in mind. I'm not sure if we're going to have to use that, but just in case. And then here we've got CD squared. So if you've watched any of my videos on similarity, and it might not even be a similarity question, I don't know. But whenever there's a something to the power of 2, it's usually because of something like this. Let's say, for example, you have CD over AB equals to AC over CD. It's usually when you've got something like that. And then when you do cross multiplication, you end up with a CD to the power of 2. So the only way that you can, the only way that you could sometimes get that is when you are using two triangles and both of them have CD. So let's go see if that's possible. It's not always going to be like that. Sometimes, let's first go see. So CD, where's CD? CD's over here. Okay, now have a look at CG. CG, where are you, CG? Okay, so there's CG, and then there's DB. Where's DB? Okay, so DB's there. Okay, so to be honest, when I draw that, I don't really see anything. I mean, there's a whole bunch of things that this could be. It could be, it's a bit challenging for now. So I'm going to leave that. What I'm going to do is quickly go to this. So we're going to write this down. FCB is similar to triangle CDB. And then, when we need to make those ratios. So for example, we can say that FC over CD, I just want to see if this gets us anywhere, is the same as, for example, CB over DB, and that's the same as FB over CB. Now, you must give a reason for this, and that is because I used to use the reason corresponding sides in proportion, but there is an easier one that you're allowed to use, and that is because these triangles were similar, so you can just say similar triangles. And as I said, what I'm doing right now might not get us anywhere, but let's just try. So what I would do now is just go look over here again, like what are we actually looking for? So we want CD, so I would go highlight any CDs that I have. There we go. CG, nothing, and DB. Okay, so we've got these two at least. I would then use cross multiplication. Okay, so I'm just going to multiply that up there and that up there. And so that's going to be FCDB equals to CB multiplied by CD. Okay, now I would try to look at these ones and see if I can replace them with, so for example, I know that I want this one, and I know that I want this one because they are both inside here. But I don't want CB and I don't want FC. So I'm going to try to see if I can replace those. So if I go to FC on the diagram, FC, okay, that wasn't the same as anything, so I can't do anything there. If I look at CB, that's not the same as anything. So what do I mean by that? Well, you see how these two are the same? So I would have liked it if maybe, they said that BC was the same as CG, for example, because then I could have replaced this one with CG, and then I could have had a CG over there. So I think what we've done here is not actually going to work, but this is okay. I'm not going to even edit this out of the video. Like, I want you to see that I don't know how this question works. I just thought maybe we should try that. Okay, so I don't think we're going to have to use the previous answer's similarity. So let's restart with a new technique. Okay, now this is very normal that this happens. Now we need to go try something else. So let's go back to our original thing. So we're looking for CD. So where's CD? There it is. And then CG. CG is over here. Okay. And then DB. DB. Where are you? DB. DB. Yeah, it's so random, isn't it? But let's see what we can do. Okay, so the only I do see two triangles. Can you see them? There is actually only two triangles here. Because if you look at, for example, okay, so we know we want to use CD twice if possible. So we could use it in this triangle. You see there's a triangle there. And then we could also try looking at this triangle. And guys, I have not looked at the memo. If you've watched my videos and you've heard me talk about this, I don't look at memos. So this is literally, you are watching me trying to figure this out in real time right now. And I have not tried this question already. I'm trying it right now with you. That's why I already tried that similarity or that other part where I used this and it didn't work. But that's okay because that's how it's going to be in an exam as well. So I see those two triangles, okay? So I'm going to try do some type of similarity with those two triangles, and let's see how successful that is. So the first step is that I tell the teacher which triangles I'm working in, and the order of the triangles does not matter right now because the teacher knows that you don't know the order right or at this moment. So we're going to work in triangle CDG and triangle CBD. Now this order doesn't necessarily match, but that is absolutely fine because we don't know the order. But you're just showing the teacher which triangles you are working in. Okay, so let's begin. So I'm going to do all the angles in the yellow triangle, and then I'm going to make those equal to all the angles in the blue triangle. It'll just make it easier. So all the yellow angles go here, and all the blue angles go here. It'll be easier when we have to name the triangles in the correct order later on. Okay, so in the yellow triangle, we've got a 90 degree here, and in the blue triangle, we have a 90 degree over here. See that? So that'll be our first one. So we could say that angle, well, we first have to say that angle G2 is equal to 90, because we haven't said that yet. We've only stated that G1 is 90. So the first step is that G2 is going to be 90 degrees, and that is just because of angles on a straight line. Okay, so then we can say that therefore angle G2 is the same as angle, this big angle in the blue triangle, which is angle BCD. Okay, so we have one angle. That is great. Good start. Some of you might be tempted to use this angle here, and you might be tempted to say that it's common, but that won't be correct because in the blue triangle, it's that size. But in the yellow triangle, it's this whole piece over here. So it's not the same angle. All right, guys. Now, obviously, I edited the part out where I'm just sitting and trying to figure this out. But I've literally been sitting here for like 14, 15 minutes already. I can't find the next part. So it's very normal, okay? But I'm just so stubborn. I just cannot look at the memo. I'm literally sitting here in my little room. And I've been sitting here for like 15 minutes and I'm just staring at the page. It's probably something so easy. This might not even be the right way to do the question. That's the other option. But I cannot look at the memo, guys. So yeah, I'm going to carry on looking. Right. So I just sat for another 10 minutes. So I've sat for about 25 minutes in total. I have finally figured it out. And you know what I did to help me figure it out? Is in some videos, I might have mentioned this before, but sometimes you're in a test, you're in an exam, and you just cannot see something. So then you got to write out certain keywords, such as look for any diameters, look for any radius or radii, all of these different things. Look for any bow ties, look for any cyclic quads. And what this does is look for any parallel lines, maybe. Look for any tangents. There's all these words that we can sometimes just write down, and it helps to trigger. And when I wrote down this one, I suddenly thought, there's a center. And then look at this, guys. That and that are the same length. So that means that this angle and this angle are the same. And that is the break that I needed to see. Well, I was literally sitting here for 25 minutes, guys. I'm not joking. Of course, I can't prove that to you because I edit that part out so we don't all sit here for so long. But I sat here for 25 minutes. I will never look at the memo. I will rather sit and struggle. Now, I know in an exam that's really stressful, but I forgot to write these words out. I should have done this a lot earlier. Okay? All these little keywords, when you write them down, it just helps to trigger your brain to look in a different way. And it's when I wrote this one down that I looked and I saw, there we go. Okay, so let's finish this up. So we can say that OC is the same as OD, and that's because they are radii. And so we can then say, therefore, angle C3 would then have to be the same as angle D2. And that's because those are the angles opposite equal sides. In the IEB curriculum, you can just say isos triangle for isosceles triangle. Okay, so then that was x, so then that means that one's x. Okay, so we are well on our way now, because in similarity, if you can already find two angles, which we've done there, and then we've done there, then the third one is super easy because of the sum of angles in a triangle. So in the yellow triangle, what have we not used? Well, we've used this one, and we've used this one, but we have not used this whole angle, okay? So that is angle CDG. So CDG would then be equal to, now in the blue one, we've used the 90, we've used this, so we have not used that one, and that would be B3. And this is just going to be because of sum of angles, whoops, that's triangle, Kev, sum of angles in a triangle. Now, because we wrote all the yellow angles on the left, so where are the angles? Well, it was this one, and that one over there. And then the blue one was that, that, and that. And that is why we can, and now we can easily come up with the order. Because you see, this order might not be correct. So now we can say, therefore, triangle, now we can just use GCD is similar to CDB. So CDB, triangle CDB. And the reason is going to be angle, angle, angle. Now I have some bad news. We're not even done because they want us to get to this. So now what we do, guys, I'm literally smiling because I'm so happy that I found the answer. So why am I telling you that? Well, the point is that when you are busy studying, okay, and you're sitting there in your room or wherever you're studying and you cannot figure it out, don't look at the memo. Like, I promise you, I sat for 25 minutes now. Now, what happens is that because I solved that myself, it sends a little bit of confidence to my brain, and it is the best feeling ever. So when I get to another one of these questions, I've got more confidence. Even though you might not realize it, that confidence inside your brain has gone up a little bit. But if I had just gone to the memo, yes, I would have saved a bit of time in my life, okay? I would have saved like 20 minutes. But I would have decreased my subconscious confidence a little bit. And in the next question that I get with these types of questions, I'm going to approach it with a lower confidence. Whereas now, I don't care that I took 25 minutes because I feel like I just did like a workout with my brain. My brain it got a bit of a challenge and I'm feeling good. Okay? Now I know that in an exam you've got time restrictions, but I'm talking about when you're studying at home like you are right now, okay? Don't rush. Like, sit there and take 20 minutes and just try to figure it out and challenge yourself. And the 25 minutes is nothing. Like, when I was in university, I would sometimes sit up to an hour. And even in high school, there were some questions where I would sit for like 45 minutes or so. And it just gave me the greatest amount of confidence in myself, so that when I got into an exam, I knew, listen, I can solve these questions. Sometimes it takes longer. Sometimes I don't see it. Sometimes I hit a bit of a blank. That's normal. There are some of you who are watching this right now who probably saw the radius right in the beginning. Just because I'm a teacher who's been doing this for so much longer, it doesn't mean that I see it straight away, you know? Some of you watching this probably saw it immediately. But that's just life, okay? And sometimes I see it, sometimes I don't. But the point is that I'm never going to look at the memo. Okay, so I hope that encourages you. Don't look at the memo. Yes, I know it's a nice, easy way to quickly move on, but decreases your confidence, and you know it does. You can feel afterwards. You feel like, oh man, I don't actually know my work. I could have said that as well. Like, I've been teaching for so long now, and look at that. I took 25 minutes to find it. Okay? Sometimes I see it immediately. Sometimes it takes longer. Okay, so now let's finish up with the question. So we know that these two triangles are now similar, right? So now what we do to try get this is we use the ratios. So we can say GC over CD, and this is where the order that you wrote this down is so important, because now these ratios have to make sense. So GC over CD is equal to CD over DB, and then that's equal to GD over CB. Don't worry the order in which you choose these. I mean, you could have chosen these two first with those two over there, or you could have done those two with those two first. It doesn't matter if you put this one first, or this one second, and this one third, or if you maybe put this one in the beginning and this one over there. That part doesn't make any difference. Okay, and then I must give a reason for that, and that's just because we have similar triangles. Okay, now we just go and highlight. And because I took so long to do that, my brain is a little bit challenged right now. So I'm literally going to go make myself a cup of coffee after this question. And I'm going to walk out this room where I'm recording and feel pretty good. Like, I mean, I've been doing this for a long time. So I'm used to this feeling of getting a question correct after trying to challenge myself. But it's a nice boost of, it's just a good feeling. It's like I've just gone and done a severe or a heavy workout in the gym, or I've gone for a run, or, I've challenged myself and it was positive because I solved something. It's a really nice feeling. So I would really encourage you, don't be afraid to spend longer times when you're busy studying. Your study time is your training time. That's where it's got to be challenging, and you've got to push yourself so that in the exam you have a better chance of being able to solve it as quickly as possible. Okay, so what we're now going to do is we're just going to go look over here, and we're going to highlight everything. So CD, there it is, and there it is. So there's two of them. That makes sense because there's a 2 over there. Then there's a CG or GC, CG, doesn't matter at all. And then DB is there. Excellent. We're just going to use cross multiplication. And so we're going to say, we're going to multiply this one up there. So that'll be GC multiplied by DB, and then CD multiplied by CD. Okay, now CD multiplied, let's just do it in alphabetical order. So CG like that, then BD. Oh no, they have it as DB. Okay. And then CD squared. And there we go. Yes, they've got it on the left, I've got it on the right. It doesn't matter. And there we solved it, guys. Excellent job. Okay, well, that coffee is going to have to wait because there's another question. Now, I'll be honest, if I was in an exam and I'd taken 25 minutes to do that, and then I get to the next one, and it's another 5-mark question, yeah, the struggle is going to really be real at that moment. So, and I mean, I took 25 minutes, so my time might not be so good, so it is stressful in an exam. I hear you guys, I know it's stressful in an exam. But that's why I encourage you to, when you are training, which is when you are studying at home, that's where you must spend a lot of hours solving these questions, taking as long as you need to take, okay? So that when you are in the exam, you have the highest chances of being able to do it. Yes, you might get to an exam and it's going to be a challenging one. That can happen. We cannot control that, unfortunately. But you just give yourself a better chance of success when you put in the effort. That's all you can do. You can still study for hours and hours and hours and get to an exam and completely blank out. That can happen. I mean, it does happen. But there's no way to solve that. The only way you can become better is just by training and studying as hard as you can and for as many hours as you can. And that is the only way to decrease. I can give you, or people ask me for tricks and tips. There is no tricks and tips. The tricks and tips, the only ones are that you write down the words like diameter, radius. But besides that, it's putting in effort, and that's how life is. You have to put in the effort. To any type of business model that you want to do one day, to anything you want to achieve, it just takes effort. Those who put in the effort do well. Those who don't want to put in the effort and do lazy, they typically don't do well. I like it because there's no magic involved. It's a simple strategy. Work hard, do well. don't work. And when I say work hard, some people are like, yeah, but Kevin, you mustn't work hard. You must work smart. When I say work hard, I also mean work smart, okay? A lot of people hear these people on like YouTube and stuff where they say, don't work hard, work smart, blah, 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 blah. So I understand that as well. I'm not saying don't work smart, but do both. Do work hard and work smart. But there's no way around it. You have to put in hours, okay? So, right. So let's do this question. So DB... okay, now when I read this, I mean, I have no idea, absolutely no idea how that question's going to work. Like, how can this look so simple and it's for 5 marks? So it's overwhelming. I get it. I'm also feeling a bit overwhelmed. But I know that with confidence that I've gathered over the years of just putting myself in these situations and then having to figure it out. Guys, when I first started tutoring, I know I'm talking a lot, but if you can skip, I guess, to the parts where I'm doing the work. But when I first, okay, so I graduated from university in like 2015, okay? 2016, I opened up my own office where I started teaching. Well, I first started in my garage at my house. Yes, I know it sounds cliche, but it's true. And after 3 months, I had enough students so I could have my own office. Okay. Then I used to have people coming to my office. Now I had up to between 4 and 5 people coming to me every hour at the same time, but they were not from the same grade. So I wasn't doing like group classes. It was like a grade 9, a grade 7 sometimes, and then like 3 or like a grade 11 and then 2 grade 12s. Now imagine that. Okay. So it's me in the classroom. I'm walking around the classroom. And as soon as a student has a question, I go to their desk and then I help them. I'm not standing in the front teaching everyone at once, okay? So I'm busy walking around. As soon as someone puts their hand up, boom, I go help them. Now imagine this. You've got like a grade 7. The grade 7 asks you for help. So you're busy standing at the grade 7. You're busy helping. Suddenly in the corner of your eye, the grade 11 puts his hand up. Okay, great. That's a little bit stressful. The stress is starting because the grade 7 needs your help, so you're finishing with that. Suddenly the grade 12 puts his hand up or her hand up. Now you have to quickly get done with that grade 7, but without rushing so that the grade 7 learns something. You then have to quickly get to the grade 11. And guess what? The grade 11's got a Euclidean geometry question, okay? And it's one of these ones where you're struggling to see it. You take 3 minutes. The grade 12 you can see is just standing there, like sitting there with their hand up. In the corner of your eye, you know it. You can feel it starting to get tense in the room. And then suddenly you get the grade 11 one done. It's amazing. You get to the grade 12 and it's another Euclidean geometry. And it's one of these types of questions. Now, I did that for like 6 or 7 years. So you can imagine how putting yourself in that situation every single day for like 6 hours every day, it trained me to be able to do this. But yet I still get to questions like this right now where I have absolutely no idea how this question's going to work. But from the years of putting myself in these situations in difficult scenarios where people are waiting for you, it taught me and it guided my brain to have the confidence to know that I can probably solve absolutely any question that is in front of me, but sometimes it takes long and sometimes it's really quick. Okay, so I wasn't just born with these natural talents. It was, you've heard my story about grade 9, grade 10, how I was failing, not really doing well. And then I just, changed my life. And then through the years of teaching and tutoring learners, it coaches you and it trains your brain to cope with any type of question. Okay? But no, I'm not like some bullet guy who's just like, oh, look at this. Oh, yeah, definitely, bro. Like just EF, quickly do a construction line here, ... Oh, alternating angles. No, it's not like that. Okay, so I've had students who solve questions faster than me many times, and I'm okay with that. I know that that's normal. I've spoken to other tutors. I've spoken to some tutors. This one lady that used to be my tutor when I was in grade 10, and she's been a teacher for like 40 years, and she says it happens all the time where learners do it faster than her. So it's okay. It's humbling, and I love it. So I'm really talking too much. Okay, so this exam, it's going to be like 6 hours. Okay, so hence prove that this is equal to this. Okay, now they said hence. Now that typically means we got to use the previous answers that we've achieved, and those were these ones over here. But like, come on, how do you go from this to this? Like, really? Okay, but let's see what we can do here. So straight away, because they said, as I said, because they said hence, I'm going to try to incorporate the previous stuff that we have. So we know that there's CD squared equals to CG times by DB. I would then look here and I would say, okay, we do have DB, so I would do that. We also have CG, okay. But CD is a bit of a random one. So what we would maybe then try to do is I'd look at CD and see if I can see anything there. I can't really see anything. I can't see, like, for example, CD is the same. Like, it's nothing like this. For example, CD is the same as DB, you know, where I could then say, oh, CD and DB are the same, so then I can change this to DB. Okay, there's nothing like that happening. So that's a bit weird. So what I would then do is try use the previous question where we had FCB being similar to CDB, and I'd go write out those ratios again, because I see it has got a CD, so that's nice. Let's rather put that as DB, and then FB over CB. Okay, then I know that the thing I don't want here is CD, so I'm going to try find that over here. So CD, okay, but now I don't know whether I should choose. Oh, okay. Another thing is that if I look here, I know that we also want, we do definitely want a DB somehow. I'm just seeing if this works out. GC, we already have, okay, there's no GC over here. And FB. Okay, you see, so that's challenging because now it's in all three, so it's difficult to know which one to choose. Okay, I know I definitely will choose this one because it has CD in it. Guys, to be honest, I don't know if this is the right approach. So, because now I feel like I'm just circling everything. Okay, I'm going to restart. I'm feeling like, oh, this is a challenging question. I won't lie. Okay, so let's just see what we have here. So, okay, so that was from the previous one. Okay, so I've wrote that there. All right, so, this is really challenging. Like, how do we get this? It just doesn't look possible, but it is possible, of course. Okay, and then I'm just going to write these ratios again. FC over CD equals to CB over DB equals to FB over CB. Okay, so these are previous questions that we've solved, okay? And they did say hence, so it has to use these. So I feel that a combination of these two somehow is going to give us that. Okay, so maybe what we could do is just go highlight all the DBs. So all the DBs, so there and there, okay. Then all the CGs, okay, so there. And then all of the FBs, so that's there. Okay. Okay, what I saw, I don't know if that'll work. Oh, and then another thing from the previous question was we actually proved GCD and CDB. GCD, and then we got to this, but maybe we also need this one over here. So that's what we also proved in this question, GCD, CDB. So GCD and CDB, so those two triangles were also similar. So let's go write that out as well. GC over CD equals to CD over DB, which equals to GD over CB. Okay. And then let's just go highlight anything that we see here. So DB, there it is. GC, we also have that one. And, C, oh no, but that gives us that. Okay. What else? Yeah, because if we do cross multiplication with this, then that just gives us that. Because that's what we did in the previous question over here. So I think I'm going to take this one away because we can get that one from here anyways, but I just want to keep this one here in case it offers us any information. Okay, so I'm going to try something. I'm going to take these two and I'm going to do cross multiplication. Okay, so if you do that, you're going to end up with CB multiplied by CB, which is equal to FB multiplied by DB. Okay, so we've got FB and DB. I know it doesn't look anything like we like. And then here we're going to have CB squared. Okay, so CB squared. Okay, then suddenly when I was looking at CB squared, I thought about Pythagoras, because Pythagoras has a square, and there are a couple 90-degree triangles in here. So if you look at CB, it's this one. Okay, so if you then look at this triangle, we know that Pythagoras says that BD squared is equal to CB squared plus CD squared. Okay, so then I'm going to replace BD squared, not BD squared, CB squared. So I need to get CB squared alone, so it's going to be CB squared equals to BD squared minus CD squared. Okay, so I'm going to replace it with that, so BD squared minus CD squared equals to FB multiplied by DB. Okay, and then from earlier, remember we had an expression for CD squared, because I don't want CD squared because it's not in here. There's no CD. So remember earlier we had this expression from CD squared, or here, remember? So I'm going to replace that with that now. So CG times DB. Okay. Now, my goodness, I'm going to divide everything by dB, because I see there's a BD squared here, there's a DB or a BD here, and there's a DB here. So I can divide everything by dB. So cancel, and then I just left with 1. And then I think we have something, guys. So now if I get BD by itself, or DB, sorry, then I just take this to the other side, so FB plus CG. I definitely think there was probably a faster way to do that, but we got it.